for the second edition of the prestigious National Conference on Resilient Infrastructure, the NCRI 2022. Let me begin by extending a warm welcome to all the dignitaries present on the dais, distinguished guests, participants, and dear friends gathered here today. This edition of the National Conference, the NCRI 2022, is organized by Kerala Highway Research Institute in association with IIT Palakkad. Kerala Highway Research Institute, situated at Karyavattam, Trivandrum, is a premier research institute under the Kerala Public Works Department that focuses on promotion of applied research and pilot projects in innovative technologies, training and capacity building, and improvements in quality of construction and material testing in the state. Indian Institute of Technology, IITs are autonomous public institutions of national importance for higher education in engineering, science, and technology. IIT Palakkad was announced by the Government of India in 2014 and started the academic program in 2015-16, admitting students to the B.Tech course in the disciplines of civil engineering, computer science and engineering, electrical engineering, and mechanical engineering. The institute can already boast of a vibrant student and faculty community drawn from the parts of the country. Now, to understand what the conference is all about, I kindly invite the faculty Dr. Rakesh J. Pillai sir to the dais. Now, to understand what the conference is all about, let me walk you through its background and the context that led to the conception of such an idea. Our state is witnessing unpredictable weather and floods. This has been an eye-opener that made us understand the need for resilient and sustainable infrastructure. The key issue, however, is the integration of academic research into field practices, which gave rise to the idea of conducting a National Conference on Resilient Infrastructure, NCRI. NCRI is a platform for bright minds from academia to discuss challenges, share information in a sustainable way, and introduce innovative and modern technologies in addition to modifications to current design and practices. The first edition of the conference was conducted in December 2020 with the theme Environment-Friendly, Climate-Resilient Designs and Construction Practices for Natural Disaster-Prone Areas. NCRI 2022 is the second edition of this national conference. Building resilient infrastructure is of paramount importance to our state. At NCRI 2022, we shall work together on the theme Climate Resilient Construction Practices, conducted in 6 prominent tracks. Through NCRI, we shall lay the foundation stones for building resilient infrastructure. With this brief introduction, I invite Srimati Hygiene Albert, Chief Engineer Design, PWD, to deliver the welcome address.
Good morning to one and all. I greet you all to the second National Conference on Resilient Infrastructure, NCRI 2022. NCRI is not just any regular conference, but is one that can bring unthinkable changes to the infrastructure sector of Kerala. Introducing the idea of climate resilient construction practices in our infrastructure can help our state in building stronger and durable structures much more resilient to the unpredictable climate of Kerala. Not only does this conference introduce revolutionary ideas and innovative building materials, but it also helps to congregate civil engineering professionals from different parts and helps to motivate and cherish the young minds present among us. It's my great pleasure to welcome Honorable Minister and dignitaries to this inaugural ceremony. First of all, I would like to welcome Honorable Minister for Works, Sri P.A. Mohammad Riyaz sir, to this inaugural function. PWD is moving successfully under the leadership of Honorable Minister Sri P.A. Mohammad Riyaz sir for the last 1 year. Many new concepts have been introduced into the department, that is a mission team, then district infrastructure coordination committee, constituency monitoring team, and these new concepts have been introduced to review the progress for closely monitoring the projects. Our minister gives prime importance to the innovative technology and is also giving full support in implementing those technologies in our department. This is evident from the transformation mission document prepared for the department under the leadership of Honorable Minister. We are grateful to Honorable Minister for accepting our invitation and coming over here as a chief guest of today's event. On behalf of PWD, I extend a hearty welcome to Honorable Minister for Works, Tourism and Youth Affairs, Sri Mohammad Riyaz sir, to this inaugural ceremony. Next, it gives me immense pleasure to welcome Sri Ajit Kumar IAS, PWD Secretary, to our conference. I am thankful to sir for accepting our invitation so as to preside this inaugural ceremony. On behalf of PWD, I extend warm welcome to Sri Ajit Kumar sir, IAS, to this function. It's my pleasure to welcome Chief Engineers, Srimati Madhumati Madam, Chief Engineer Administration, Srimati Beena, Chief Engineer Buildings, Sri Ajit Ramachandran, Chief Engineer Roads, Sri Ashok Kumar, Chief Engineer Buildings, Srimati Seja and Jacob, Chief Engineer National Highway, Srimati Lissy, Chief Engineer KSTP, and Sri Rajiv, Chief Architect, to this conference. It's my honor to introduce and welcome the keynote speakers to NCRI 2022. We have keynote speakers from IIT Palakkad, Mumbai, and Tirupati. As KHRI is in constant touch with the IITs of Palakkad, Mumbai, Tirupati, and Madras for its constant guidance for piloting projects and innovative technologies. So it's my pleasure to honor and to introduce them. We have Professor N. Raghavan, IIT Madras, Dr. Satish Jain Consultancy Engineers, Professor Geetam Tiwari from IIT Delhi, Professor Arnab Banerjee from IIT Delhi, Professor Ankit Gupta, IIT, Dr. Minimol Kurulla, McCaffrey, Dr. Anush K. Chandrappa from IIT Bhubaneswar, Dr. Rajesh Krishnan, Dr. Professor L. Boeing Singh from IIT Guwahati, Professor Dharamveer Singh from IIT Mumbai, and Dr. Rakesh G. Pillai from IIT. Sir is also Coordination Secretary of NCRI. I welcome, on behalf of PWD, I welcome all keynote speakers to this conference. I also welcome Professor Manu Sandhanam, Dean IC and SR IIT Madras, and Professor Radhakrishna G. Pillai to this conference, as they have helped a lot in piloting projects and research works. One of the guidelines will be releasing today by Honorable Minister regarding durability of concrete. This is the end product of our work of KHRI with association with IIT Madras. I also take this opportunity to welcome all the dignified guests who has accepted our invitation. We have chief engineers from other departments, from representatives from engineering colleges and other departments. I welcome all to this program. Last but not least, I welcome the entire team of NCRI to this conference who have worked hard for this event. It's a moment of great pleasure for me to welcome you once again to this event. Thank you.
Thank you, ma'am. Next, I invite Sri Ajit Kumar IAS, Secretary, PWD, to deliver the presidential address.
Honorable Minister, PWD, Government of Kerala, Shri P.A. Mohammad Riaz, all chief engineers sitting on dais, all the dignitaries, all professors who have come from outside, we welcome you at Kerala. I just want to keep it very short because Honorable Minister has to go for a meeting, and moreover, the conference should be more, not this ceremony. So I have just 2-3 points to say that this resilience infrastructure is such an important thing that the Economist magazine publishes Safe Cities Index of 60 cities of the world. Resilient infrastructure is one of the very key parameter of judging the safe cities. Second point I want to mention that this national conference may evolve a plan for nation, but our state or all the states are different from each other. So there should be a plan which can be locally implemented in Kerala with its own climate. We have a lot of issues with climatic conditions like rain, landsliding and all. And third point is that maybe we can learn from the past. Our ancestors or in our history, there have been very good important, you can say, examples of good construction practices in architecture. Maybe we can think of, just revising them also. So I'll keep it short. I'll invite now Honorable Minister for his inaugural speech. Thank you very much.
Sri Ajit Kumar IAS, Secretary of PWD, who is presiding this conference, dignitaries, professors, chief engineers, friends. At a time when Kerala is discussing climate change and its various effects on our social life, a very significant national conference is being organized under the leadership of KHRI in collaboration with IIT Palakkad. I congratulate the step taken by KHRI and IIT Palakkad. Kerala is the state that has been severely affected by climate change in recent times. We all know that. Now the majority of months are in a special type of rain, which is damaging the public works also. In very short time, very heavy rain is now happening in Kerala. One of the most affected government departments is the PWD. It is certain that the National Conference on Resilient Infrastructure and CRI will put forward concrete proposals and solutions in that seriousness. Introduction and discussion on innovative construction methods with high resilience in the fields of roads, bridges and buildings will be part of this conference. Papers are presented on these topics by internationally renowned experts. It is very happy to have such experts who are participating in this conference. It is our responsibility to find out what is suitable for Kerala and implement it. It has been 1.5 years since I took charge of this department. You know that this government, LDF government, again came to power in 2021 May. A continuous study of the department and construction methods was attempted during this period. There are still some things that need to be clarified. Earlier we mostly discussed about floods. We are trying to adopt methods for building roads and bridges to overcome any flood situation in future. We have to check the weather pattern, especially the change in rainfall pattern day by day. The weather conditions are such that it will rain heavily in a short period of time, which I have said before. More water reaches the roads than the land can absorb. In many places, such rainfall is more than the drainage capacity. That is one of the important issue now the Kerala is facing. Due to this new pattern of rain, this new issue that the rainfall is more than the drainage capacity, we must address that issue also. As the water takes longer time to be absorbed, the roads are affected by it. We need to look into this specifically. Here we are discussing resilient infrastructure focusing on 6 areas. I have gone through the notes and about the agendas. Structural resilience, safety and resilience of transport systems and climate resilient infrastructure. In a state like Kerala, high population density, high traffic density and limited resources should also be kept in mind to arrive at new projects. We need projects that last longer. That is very important. I underline, we need projects that last longer. In Kerala now the situation is like it is raining for 8 months in a year. The majority of months are raining now. For 8 months, the roads has been submerged in water. It's a major reason for the road to collapse. There is a situation where more vehicles are arriving than what can be afforded there. Therefore, we must discuss more sustainable construction methods. Cost-effective construction is required. In the past, bitumen was not available during the rainy season. There the emulsion was developed. You have to move on from that. Technology should be used to find life-giving materials along with water. The aim should be to reduce the exploitation of natural resources. We used advanced techniques like FDRM, full depth reclamation method. There we have to explore the possibility of using it in all areas. We have to find new techniques in green building methods in building construction. We should be able to use construction methods using precast materials. The way we use steel structures and steel composite structures has to be, if there are more weatherproof construction methods, such things should be checked in this conference. Kerala is ready to adopt such innovative systems. KHRI is elevated as a center for excellence to lead it. KHRI should be able to lead such activities. Special thanks to IIT for providing necessary support. I am happily inaugurating this national seminar. Thank you all.
Next is the release of our NCRI 2022 proceedings. I kindly invite the Honorable Minister to release the NCRI 2022 proceedings by presenting to Professor Manu Santhanam, Dean, IC and SR. Sir. On this momentous occasion of our Golden Jubilee, we are delighted to launch our revamped website, A Stride Towards Digital Era. Next is the release of guidelines for durability design and performance specifications for concrete structure. I invite the Honorable Minister to release the guidelines by presenting to Srimati Beena L., Chief Engineer, Buildings. I also invite Dr. Manu Santanam and Professor Radha Krishnan Pillai to the dais. Sir, one more release is there. So many are. KHRI is celebrating the 50th year, so I kindly invite Ajit Kumar IAS. I kindly invite Minister to release the souvenir by presenting to Ajit Kumar IAS. Memento. On behalf of the entire NCRI team, I wholeheartedly thank you, our Honorable Minister for Public Works, Sri P.A. Mohammad Riaz, for gracing this event with his presence. As a token of our appreciation, we would like to present a memento to Honorable Minister. I kindly invite PWD Secretary Ajit Kumar IAS to present the memento. Thank you, Honorable Minister. Thank you, Ajit sir. AM University, College Stations, USA. I kindly invite Dr. Manu Santanam and Professor Radha Krishnan G. Pillai to the dais.
on that screen. You can. Yeah. Yeah, good morning. Okay, so as you have seen, we have released a small book on guidelines for durability design and performance specifications for reinforced concrete structures. And I am Radhakrishnan, and we have worked on this book with Professor Manu and Dr. Deepak Kamde. So I am actually going to go through what we have in that book in the first half of the book. And then Professor Manu will kind of continue on talking about performance specifications. So let's see a little bit, not just exactly covering the book, but okay, so this is a photograph of a bridge in the northern part of Kerala, and it's, as you see, it's on the coast or running through the sea, I mean just above the seawater. And what we are seeing is this just about 10-year-old bridge, and lot of corrosion. I'm not showing the close-up pictures here, but there are a lot of repairs already happened on this bridge, and then that repair also failed after about 5-6 years. That means it was not able to control the corrosion. So we have lot of concrete structures or public infrastructure systems like this, bridges which are running along the coast and experiencing severe corrosion, and not like they are actually designed for many more decades and not just one decade. Okay, so the big question is what happens to this design life, and what is the difference between the design life and the actual life which the bridges are able to provide or they will have. Now problem what we are talking is how do we control. Now, I would say today that it is not that we do not have technology. We do have technology to build durable structures which can last 100+ years, but there is so look at this like an in-house program here. So it's all PWD programs. So we have to be some truths, like we really have to modify or update our design practices and adapt the new technologies. Because most of the time what happens is, we look at what has been done in the past and then we hesitate to make changes. So this initiative, when we started talking to KHRI about 2-3 years ago, in fact the request was from KHRI to come up with a book on durability design and performance specifications, and we were working in that area for 2 years, and we actually worked on this bridge also to look at, because having such a bridge, and it cannot just go, we cannot let these things happen on many other bridges in future. So we are constructing a lot of new structures. So the idea is, can we adapt or adopt these new technologies in terms of structural design and material specifications. Today we are going to focus mainly on the material specification and durability design. So just like we say structural design, where you think about mechanical properties of the concrete or steel, we are talking now, when you talk about durable structures, if I want a structure to last for 100 years, you have to really think about chemistry. It's not just mechanics, you have to start thinking about chemistry and how do we bring in those chemical properties of steel and concrete into the design. It is a must, otherwise we can't talk about 100 years service life. We have to, because there is a myth that, increase the strength, you will automatically increase durability, which is not always correct. There may be cases which are correct, but not always. And most of the time it is not, especially when we consider the field properties. So it's a very short presentation, just talking about gist of these ideas. And so when you talk about service life, you can see that, the picture on the left side, this doesn't work here, right? Okay, the insert there where you are talking about the red circles over there, imagine that is the chloride from the seawater or airborne chlorides. It penetrates through the cover concrete and there is a black circle at the bottom, which is the steel rebar. So the time taken for these chlorides from the surface to the steel rebar, and what is the cover depth? Let's say assume, and it can be anywhere from 0 to cover depth, right? So that's another challenge. I'll come to that next slide. So let's say the cover depth is about 2 inches. And if you want 100 years of service life, you want to control the concrete or make the concrete in such a way that the chlorides travel through 2 inches in 100 years. Okay, and only 2 inches in 100 years. So that makes this whole process very complex and very difficult or challenging to design and practice. And the propagation phase, usually when we say, like, when steel starts corroding, you might not get more than about 5-6 years before you actually do a major repair or replacement. So in practice, I would say don't even think about the corrosion propagation phase. So idea should be that we prevent the steel from initiating the corrosion, not how long it will take after corrosion initiates, because you will need a lot of money to do anything beyond that time. So if you can modify our concrete, and even we don't need to do anything to the steel, ideally speaking, we can just work or put more money on the concrete and have a good on-site practices, you can really achieve very, very long service life than what we see today. And there is also one more thing. When I say service life, I really mean corrosion-free service life. Not a service life where you keep on maintaining, spending again lots of money and keep on putting more and more money and then maintaining the structure. That is not what we are talking about. There is no much charm in doing that. It's like do it once and forget for 100 years. Can we design structures like that? So that's the idea here. Now this is that cover depth thing I was talking about. So there's some analysis we did, and what we found is if you can make sure that the cover depth is as per design, probably you will avoid 90% of the problems associated with corrosion. Okay? So this was made by, this slide was made by Dr. Jayachandran in NIT Calicut. So he looked at this different cover depth and how for a same concrete, if cover depth changes from 30 to 40 to 50, you can see the life changes from 40 to about 50 years. So you can see how important the cover depth of the concrete is. So please don't allow people to walk over the rebar when just before the construction, and make sure that these cover blocks are really very good and put in a right place. Right place means not in between the rebar, but they should be below the rebar. Okay? And that at the time of vibration of the concrete, not before you place the concrete. Most of the time this is what happens. You place everything and then if you don't tie them properly, when you put the needle vibrator, that will also vibrate and then move away from the rebar. I have seen many places like that. Another thing is we put brick pieces as cover depth, cover blocks. Please don't do that, because that will create a weak location right where you don't want a weak location. Okay, weak in the sense, not the strength mat I am talking, what I am talking is it's a place through which the chlorides will easily pass through them. And sometimes we look at cover blocks which will look very good, smooth finish. That's not what we want for cover block, because we want that cover block to bond very well with the parent or adjacent concrete. So it's better to have a rough surface cover block, but use it with the same concrete which you use. You don't have to have a cover block which has double the strength than the parent concrete. That's also another thing which happens. So these are some of the things which we need to really think and implement. And how can we ensure that this cover depth is really practiced? Put a test after the formwork is removed. So you put in the contract specification that cover depth will be checked after the removal of the formwork before the final payment. That also is important. I don't know if we can do that everywhere, but put this as a specific performance specification. Now then other thing is looking at the corrosion initiation. So this goes only one way. Okay. Yeah. So we talked about the initiation of corrosion. That's our key thing to control, not the controlling corrosion rate. Why I say very specifically is if you talk to a steel company, they will say my steel has a lower corrosion rate. And for concrete structures, that is not the thing which we should first look at. We should look at how much chlorides is required to initiate the corrosion. So higher the chloride requirement, longer the life. So don't worry about the corrosion rate. That is second stage. We need to worry about the first stage, which we call corrosion initiation phase, where corrosion, because in steel companies they actually talk about steel in direct connection with the corrosive media. In concrete structures it's not like that. For several years chloride will not be near the steel. It takes time for chlorides to reach the steel. So because of that difference, I think civil engineers should ask the metallurgist that I need a steel which will have higher chloride threshold and not necessarily low corrosion rate. Now, so chloride threshold is a key parameter, and Jayachandran is here. He was the one who started working on this with me in IIT Madras. And we developed a test method where we could find what is that amount of chloride for different steel cementitious system. Okay? So, if you put fly ash in concrete, the chloride threshold might change for the same steel. So, we have this database now. This is also included in this book. We have this database looking at different values for different steel cementitious system, and we looked at corrosion inhibitors, pre-stressing steel, coated rebars, and that's one other thing I want to say. Please don't go for coated rebar. We have very clear evidence that coated rebars will have very, very low service life as compared to an uncoated rebar. Okay, because the scratches on this coated rebar will really, very adversely it will affect the service life of the structure. So you spend more money for getting coated rebar and get an inferior product. You can think whether you want to do that or not. So it's not advisable. And corrosion inhibitors is another thing which can be mixed with the concrete at the time of placement, and that helps in providing a layer around the steel surface which helps in increasing the amount of chloride required for the corrosion initiation. That means it's going to be more corrosion resistant for in the same concrete. And we did this study, and then you can see this difference in the average time or the median time required for the corrosion initiation. If you don't have corrosion inhibitors, for this particular case it was, let's say 9 years, let's say 10 years. The moment you add corrosion inhibitors, you could get up to 30 years of life, 2 to 3 times more depending on the quality of the inhibitor, but it is possible to increase the service life by up to 3 times. Now another thing is this big myth about everybody talking, like whenever it is we say use fly ash, use slag in concrete, people say it's a waste material. Why should I use that waste material? People think like it's an impurity you are adding to the concrete. Please remember, it is not. Okay? It really adds a lot of value and lot of resistance to the chloride ingress and also the corrosion resistance. Okay? Both. So it's really a good material. All these materials are very good, and in fact we have used this in one of the bridge project in Kollam, and now I think the news has spread that this slag concrete is very, very good, and then people are trying to use it in Kerala now. So fly ash and slag, if anybody says we can use it, please adopt it. There are enough guidelines available on how to use it. They are very good materials. Now looking at this, like I said, the chloride threshold, it is a very important parameter. So when you use this, one thing which people might tell you is that the chloride threshold decreases when you use fly ash. But that is not what we have to look at. We have to look at, there is an added feature also. Reduction in chloride threshold is one thing, but it also helps in reducing the speed of penetration of that chloride through that cover depth. So that is a much more positive effect. So what we see is looking at the service life. So even though the chloride threshold were reducing, you can see that in case of fly ash concrete, PPC is fly ash, the brown one, and the black one is the OPC concrete, which has about 50 years. This is a case study. If you put fly ash, you could get 80 plus years, almost double the life. It is possible to do that. Okay. Now, so please go for PPC or PSC type concretes. Now, looking at again chloride threshold when you put the corrosion inhibitors. So, the third one, the square and the diamond markers, they are actually the systems with fly ash, but with corrosion inhibitors. So, you can really see that it is again matching with the blue markers, which is OPC concrete. So, you have really, there is no problem. So, the agenda here is to tell you that the use of fly ash and slags are very good for enhancing the service life. Now, look at these numbers here. The black one, OPC concrete, you can have a life of about 50 years, assume a particular case. And then in that case, if you actually replace that with fly ash concrete, you could get about 90 years. And if you put a little bit of corrosion inhibitors, you could raise the life by another 10 or 100 years and even up to 120 years, depending on the dosage of the inhibitor. So, the mantra here is use fly ash or slag and also use corrosion inhibitors. Both these can be mixed with the concrete and you could get almost more than double the life, service life. Okay. So, I think I am pausing on this slide. This is very important slide to sensitize on this advantage of use of this corrosion inhibitors and fly ash. Now, there is a software which is available if you want to do durability design, this software called Life 365, which is freely available. So, you can download and start playing with that software, which was developed by ACI and then this group of companies in the US. 365 is not a number you cannot forget, number of days in a year. So, life365.org, you can download this. Now, we developed because if you tell somebody to design, learn software, there will be hesitation. Sometimes we need superior or senior bosses to get convinced quickly. Okay, so that's so we made this nomogram where you can actually so this zone 1 top left is for the design office, where they will design the cover depth. D, they will tell what is the cover depth. You pick one of the line and then go to the right side and then decide what type of cement you want to use and what type of steel you want to use. Once you decide, go down. So, the top 2 is happening in the design office, structural and material design office. The third one happens, or it gets altered at the site, depending on how you mix and cure, place, everything. So, that is the diffusion coefficient of the, or chloride diffusion coefficient, or the rate at which the chlorides penetrate. So, that is the diffusion coefficient. So, you pick one of those curves and say that I want to design for this mx dy mix. Usually when we talk about what type of concrete you want to use, people say I want to use M something, M20, M30, M40, that, and we stop there. So, M is for mechanical, only you do not get any durability parameter, it is not specified. So, we need to start specifying durability parameter when we talk about concrete. So, we are propagating this, the way by which we should call or name the concrete. What type of concrete? It is M50D2, something like that, or M50D1. That means the diffusion coefficient is 1 and compressive strength is 50, characteristics values. Okay, so, this is the idea. So, like I said in the very beginning, you need to think both mechanics and chemistry if you want to talk about durability. Without thinking chemistry, you can't get durability. So, that chemistry is coming from this diffusion coefficient, so by which we make the good quality concrete and get this diffusion coefficient. Now, so here this is the things like provide adequate cover depth. This is my last slide. Provide adequate cover depth. We need to know what is the chloride threshold and chloride ingress rate, with which we can actually look at the service life and design for it with fly ash, with slag, etc. And at the end, when in the contract specifications, see if you can do this. in your next contract specification, can you define a durability specification? MX dy concrete. Now, Professor Manu will talk about how do we get this dy in the field. You know, because some of these tests are long time, so we are talking about different correlations, and there are also some simpler tests which you can do, and KHRI has a very good lab right now. We were there yesterday to do all of these tests also. So I would really appreciate the KHRI team for coming up with this good concrete durability lab. Okay. Thank you very much.
Thank you, sir. Next, I invite Dr. Manu Santanam, Dean IC and SR, for presentation.
Presentation. Okay. Good morning, everybody. Indeed, a pleasure to be here, and very happy to interact with a room full of people who are interested in concrete and infrastructure. And I think I should definitely say thanks to KHRI for making all this possible. I think they've been very proactive, and like Dr. Pillai said, they've really been at the forefront of this change that is needed to really make our construction durable, concrete construction durable. And I think they will go a long way in proving Kerala to be a model state where we can actually implement these specifications in a better way and control the quality of our concrete that we are putting out. So with that foreground, let me go into the second part of this coverage of the handbook that we have just released on durability design and specification, prescriptive and performance approaches. The idea is just to give you an introduction to what is explained in the book. I hope all of you will get yourself a copy of this book once it's fully finalized. Actually, the version that was released today was sort of a semi-complete version. It may still need a little bit more of a touch-up before it's in the hands of all the engineers. Nevertheless, I'd like to present the other part, that is, as Professor Pillai was saying, how do we actually ensure that the performance is actually there in the structure? What do we do for that? Can we do something before we actually start the construction? And that is something which performance specifications help us tackle. So again, conventionally, we always think that as long as you design your concrete with adequate compressive strength, you achieve the durability. As Professor Pillai said, MX or M30, M40, that's the concept that we typically design concrete with, and say that, okay, as long as your concrete has a correct strength, we assume that it's going to be performing quite well. Okay. However, we don't, of course, to do this, we specify a cement type, binder content, and say that the concrete should have a maximum water cement ratio of so much and so on. Cover, again, as again Dr. Pillai gave that example very clearly, we generally specify the cover for a particular service environment. We say that for extreme, it should be 75 mm for the columns, and so on and so forth, right? But how often do we actually check it? Cover blocks, yes, cover blocks should be in place. One should do a proper inspection of whether the cover blocks have been properly placed. But after vibration, what happens? Sometimes, and as another example, as Dr. Pillai was saying, people start walking on the rebar. Again, all that leads to a change in the cover. So how much cover are we actually getting in the structure is what's more important than what is actually designed for, right? So all of these things lead to the fact that research and field experience have shown that this reliance on compressive strength is something that does not really work as far as the durability of the concrete is concerned. So we have to take durability in its entirety. We can't just think about fixing material specifications and saying that durability is all because of the material. The way that the material is put together in the structure is also very important. Increasingly, we see structures where a lot of concrete is placed in large sections, sections which are larger than 1.5 meters. So we need to start thinking about the temperature of the concrete also as a very important criterion, right? The other process of making the concrete, like mixing, transporting it to the site. Sometimes if you don't do a good job of transporting, depending on the type of the mix, you may end up having segregation of the concrete, and you don't get a uniform quality of the concrete when you're actually placing it in the location. So you don't want that to happen, because ultimately all that you've worked for with the mix design will go to a waste if you're not taking proper care of the concrete while transporting it. Compaction, curing, all these obviously are strategies that lead to durability, but how often do we check whether these are being done correctly or not? Curing, especially, all of you would have seen poor examples of curing in every construction site, right? You would have seen that people have put the Hessian cloth or jute cloth on top of the concrete. It should be wet all the time, but how often do we see it completely dry? We don't see it wet all the time. So that means curing is not effective. And problem, what happens is, we talked about fly ash and slag. If we don't do proper curing, it's likely to hurt these concretes a lot more than it hurt the usual. Of course, it hurts all concrete if you don't do curing. But when you don't do curing with concrete which has specialty materials, it hurts the concrete even more. So you need to ensure that curing has to be done properly. Temperature is getting increasingly important, because we're dealing with concrete construction, especially for metro construction, pillars and all that. Those are quite large, 1.5 meters, 2 meters thick, right? One needs to start paying attention to the thermal stresses that come because of the high temperatures reached in the concrete because of the heat of hydration, right? We're using typically grades of concrete over M45, M50. In such cases, we have higher cementitious content, so more temperature, right? One needs to start paying attention to these aspects. So all this also has a impact on the durability of the concrete. Workmanship, okay, I don't have to say much there, because all of you are clearly seeing the effects of poor workmanship, right? This lack of curing is also an effect of poor workmanship, right? Proper surface quality, sometimes we don't achieve that. If we don't do a good job of early curing for elements such as slabs, we get plastic shrinkage. Those may not be very structurally important, but those are going to lead to poorer durability of the concrete. So workmanship is an aspect that has to be paid attention to. But how do we actually address this? We have said that, okay, choose this cement, choose so much of this cement, choose this water cement ratio, and lo and behold, you get a durable concrete. But all of these other aspects, how do you bring it in? Where does it all come in? It comes in the specification. How do you change the specification? How do you bring in these parameters to reflect the actual quality of the concrete that is there in the structure? And that's what we need to think about. On the other side of durability, of course, you have the environment, and that's what you need to also define carefully. What type of environment are you doing the construction, and what are the primary mechanisms of deterioration of the concrete in these environments? So again, as Dr. Pillai pointed out very clearly, chemistry, understanding chemistry is very important. It's not just structural mechanics. Concrete structures, you need to really be careful and understand at least the basic chemistry, if not the entire chemistry of the concrete. So overall, there are two general approaches to achieving durability. One is the prescriptive approach, the other is a performance approach. Okay, prescriptive could be of two types. One is avoidance of deterioration. Like, we assume that when we use an epoxy coated steel, all our problems are solved. We don't get corrosion. Is that correct? No, it is not really correct, right? We think that we put this coating on top and corrosion is gone. It's not correct. That coating has a life. Secondly, that coating really depends on how the bar is handled on site. If the bar is not handled properly, especially while bending and so on, and the way that they store the bars on site, the coating starts breaking. It's very brittle. It's very small, first of all. It's only hardly less than a micron thick. It starts breaking, and because of this breakage, you may have local sites of corrosion that are going to cause corrosion problems much faster than if you use a conventional reinforcing steel. And research has also shown this coating basically affects the bond. So we are not making a right choice by that. Stainless steel, we can use stainless steel, yes. But then, is the economics justified? Can we actually say use stainless steel for this project just because it's not going to corrode, where as Dr. Pillai showed, it's much more useful to pay attention to the concrete quality and effect changes in the concrete that can lead to the corrosion-free service life, right? So that's what one needs to pay attention to while doing design of concrete. The other is what we today do deemed to satisfy approach. We place prescriptive requirements on the materials, right? We say that use this cement for this environment, use so much of this cement, use this much water cement ratio, and so on and so forth. So that's the prescriptive requirement or deemed to satisfy approach that we deal with in today's codes. But we know that it's not working. We know that our structures are not really being durable. So there's an increasing need to shift towards a performance approach. For instance, using tests and indicators. Now I'm saying that I'm designing concrete for a coastal bridge in Trivandrum. So what do I need to worry about? I need to obviously worry about chloride-induced corrosion. I can't just say that use the concrete with so much water cement ratio, you're fine. No. I need to show the performance. And how do I do this? My structure is going to last for 50 to 100 years. How do I show that that performance will actually be met? I need to set up short-term tests, accelerated tests, which can still capture the real mechanisms of how this damage will manifest in the field and pick out some very useful indicators that people can use in engineering to define the quality of the concrete. One such indicator being the diffusion coefficient that Dr. Pillai talked about. Of course, there's a whole lot of other indicators which are there in the book. Book covers fairly extensively. Of course, it does not give you the complete background, but at least it tells you what are the tests are there to actually do the assessment of durability properties. So indicators are important to understand the role of the concrete ingredients in achieving a particular level of durability. So with that, we can do a qualitative ranking of the concrete and choose our mixes carefully to design for a particular environment. These days, of course, there are software programs that can help you do these kinds of things also. And the kind of nomograms that we have developed at IIT Madras are really going to be a big tool in the hands of engineers to do this kind of an assessment. And of course, once we gain confidence with this, we can go to the next stage, because obviously you can't keep testing all the time. So one has to be able to do sufficiently good modeling to estimate the service life of the concrete structure, right, by appropriate models that incorporate these design approaches, that incorporate these durability indices. So that's the next stage. I don't think we've reached that stage yet. We are still in the performance-based tests and indicator stage that can be readily applied to any construction project. And that's where we hope that this book or this guideline will enable our engineers to take that step forward to really take our construction in the next direction. So just to give you examples of performance and prescriptive specs, I'll just probably give you examples of something which you are more familiar with earlier. Let's say this light bulb. You go to an electrical shop, you want to buy this light bulb. You don't say, okay, I need, of course, you think about the wattage because you know that that gives more power and so on. But you don't say that I need a tungsten of thickness 0.3 millimeters and so on and so forth. What do you ask for? You say, I want a bulb with this wattage. And what does the shopkeeper do? The shopkeeper takes the bulb, puts in the socket and sees whether the bulb is working or not. And you get the same bulb. Bulb is working. Performance has been shown. Another example, you want to place an order for a computer on Amazon. Okay, you've worked out some specifications. Let's say you want a terabyte of hard disk drive, you need 8 GB RAM and so on and so forth. You put all this together and you place the order, you get the computer, you turn it on, everything works fine. But when you want to actually make your software work in that same computer, it is not working. So the prescription was okay, satisfied by the company, but the performance which is required for you is not getting satisfied. So similarly, in construction, the prescription can only get you a certain structure. The performance need not be 100% met by that prescription. The performance needs to be perfectly tested in order to be certain about the construction process. So just to give you an example, when we specify a compressive strength, that is a performance specification, right? We are checking compressive strength at the site also. We make these cubes, we store them in ideal conditions, and we check the strength at 7 days, 28 days. If the 28-day strength is not matching our requirement, we raise a non-conformance report. All this has to be sorted out then by doing non-destructive testing or core testing, and then after that you need to prescribe a repair mechanism to actually ascertain the correct strength of the concrete in the structure and propose how to actually enhance the strength in the structure, right? But these are based on actual performance measurements. Cover depth, as Dr. Pillai said, use a GPR or a cover meter to measure the cover post-construction. So when you specify the cover on paper saying that for this environment use this cover, that's a prescriptive spec. But when you measure the same cover after construction, it is a performance spec. What advantage does that give us? It ensures that whoever has done the job has paid attention to the fact that cover blocks remain in place while the vibration is being done. Cover blocks don't get dislodged. You get the quality that you desired. And you'll see if you use any model which talks about durability or service life, a major part of that model will be dependent on the extent of cover that is there. As long as the cover is sufficiently good and in good condition, you are definitely going to get the right level of durability in most cases. Okay? You can adopt more complicated performance parameters also, like shrinkage or permeability of the concrete. Okay? These are a little bit more tricky in the way that they can be adopted. I'll give you some examples a little bit later on. So the emphasis here is on the requirements of the finished products, that desired outcomes of construction. So here, I don't tell a contractor that in your concrete, you must only have 30% fly ash. No, contractor can make his concrete with 80% fly ash also, no problem. But all these performance characteristics need to be met. What do I want in the structure? I want a particular structural grade, I want a particular durability, and I want the workability to be good so that the workman can place and compact and finish the concrete without any problem. Why am I worried about how much cement is there, how much fly ash is there, how much slag is there? As long as I get the performance, why should I even bother what is inside? So that's the idea. Of course, I don't think we have matured to that stage yet, but we want to get to that stage where we don't question what's in the concrete as long as the performance is good. When you go and eat a nice biryani in a hotel, you don't ask how much this masala, how much that masala you put in, right? You eat it, you feel good, performance is satisfied. Okay, so that's very important. That's what we're talking about as far as concrete is concerned also. Prescription, of course, is your curing duration, minimum cement content, maximum water cement ratio. That's what we typically do. The idea is that it gives the methods, materials, processes, and procedures that instruct exactly how to carry out the work. So the options available to the contractor are few. So when we say that you have to follow IS 456 as far as design of concrete is concerned, and you have a very good source of, let's say, rice husk ash in your locality, but your IS 456 prescribes a certain type of rice husk ash with a certain property, what you have may not exactly meet that requirement, so you are constrained and you don't have the ability to use this material. Whereas for purposes of sustainability, it makes sense to actually replace cement by some of this alternative materials, right? So again, but please remember one thing, even though codes may say anything, it also says very clearly in fine print that the engineer on site has the authority to make the decision in favor of some technologies which have been proven to show a sufficiently good performance. Nobody is willing to take that risk. Everybody wants to say, okay, code says I'm going to do only this and not beyond this. Engineers have to really step up. And how do engineers get the confidence? By looking at such data which has been published in tons and tons of research. We are talking today about fly ash and slag. Fly ash has been in use for 80, 90 years. Okay. Fly ash like materials have been used for 2000 years. So why are we still worried about why fly ash is there in concrete or not? It's been proven. People know about this. Okay. As an engineer, one has to be able to take that step, but then the engineers have to be conversant with concrete technology. That often in our curriculum, we don't really pay much attention. We say that, okay, learn structural design, that's good enough. Concrete technology is going to solve 90% of the problems you have on site. As long as you pay attention to concrete, 90% of your problems on site will get solved. Right, so again, I'm not going to define this. Again, performance specifications are the set of requirements that govern the overall performance of the structure. So just to outline the challenges, I mean, I've said that performance specs are great, but what are the challenges? Obviously, this cannot be something that you can go tomorrow and apply on a construction site. As I said, one has to be conversant with the concrete technology, understand deterioration mechanisms, understand transport mechanisms, because transport mechanisms indicate the ways in which fluids or aggressive chemicals can get into the concrete. Is it by absorption? Is it by pressure of water which allows water to go into the concrete? What is the mechanism by which this is happening? Because based on that, you will choose the right test method to reflect the quality of the concrete. If you want to do a test that does not really reflect the kind of problem the concrete is going to face, you are not doing a good job of selecting a good durability test. Okay? So identification of durability parameters and test methods for a particular environment is very essential. Then, of course, assessment of durability through service life prediction, through modeling. So all that, of course, is a challenge that needs to be still undertaken. These nomograms which we have developed will go a long way in the stopgap measures to really get this done on site. So again, just to put the entire process of specifications, one is the input, which is you understand what mode of deterioration will happen, understand the exposure environment, and you select the right test methods for durability. So for Trivandrum, which is on the coastal side, obviously, you'll choose durability indicators that are more related to chloride exposure, right? You'll say that I'll choose a chloride penetration characteristic. I'll choose a diffusion coefficient of chloride to define my durability of the concrete, right? If you are, let's say, further inland, if you are in, let's say, the hills of Munnar, right? There's no chloride there. It's far away from the coast, at least 50 to 60 kilometers inland. You don't really expect airborne chloride to be a problem there, but you need to start worrying about other things. What are the major mechanisms of deterioration in Munnar? Primarily, it's just water, right? It's just exposure to copious amounts of water. So you need to protect your structure against too much entry of water. So water permeability could be one of the options that you look for as one of the strategies to define durable concrete. If you go to cities like Bangalore, further inland, but again, they are not exposed to any chlorides. Water, yes, once in a while, but most commonly they are exposed to carbonation. Carbon dioxide in the atmosphere can get increasingly high because of urban centers, lot of pollution, lot of CO2. You need to design your concrete to have good carbonation resistance. So all of these need to be understood to design, okay? And then based on this, you get the outputs, which is specifying limiting values considering both environment and binder type. Let's say I've chosen diffusion coefficient. To give you an example, in the Mumbai Trans-Harbour link that they are actually doing, one of the requirements is for the migration coefficient of concrete. That's a very particular test method called the accelerated chloride migration test. You get a parameter known as migration coefficient, and they give a specification of less than 2 into 10 power minus 12 square meter per second. And that's the coefficient units that you get. So that's the specification for concrete durability meeting the migration requirements. Okay, migration is well linked to corrosion as per several models that you have available in the world. So again, that gives you a very clear estimate that you produce concrete that meets that requirement. Okay, so that's one of the examples. You can also say, okay, water absorption of this concrete should not be more than 6%. Now that could be another requirement, right? The other important part of the performance process is to check on the quality of construction. Now very often we make cubes with the construction, we put it in an ideal condition, and we test strength and durability on those cubes. But what is the actual condition in the structure, right? You can get completely different results when you actually measure the performance in the structure. So as long as the quality of construction is met in the structure, only then you are guaranteed durability. So this performance measurement should not just be restricted to your concrete cubes. There has to be some element of it addressing the quality of concrete in the structure also. Okay? And then, most importantly, give clear instructions regarding non-compliance with specification. Now, see, all this is based on tests that happen at 28 days. Structure is already there. 28 days, a lot of your concrete has already been placed and it has matured to 28 days. If anything wrong is there, you can't say that, no, tear down the concrete, I want to put again. It's going to be very difficult. You meet the strength, but you don't meet the durability. What do you do? That's what you need to make a clear assessment of. So for that, you need to really start thinking about how do I approach this aspect of bonuses and penalties. So you tell a contractor, I need this quality. If you get me 10% more than this quality, I'll give you a bonus. If you get me 10% less than this quality, you are in for a penalty. But that has to be agreed upon and built into the process well before the construction is undertaken. Unfortunately, the way the construction is undertaken in our construction sites today, concrete mixed design is due 1 day before the concreting is about to start in construction. That can never happen. I was once speaking at a conference talking about concrete mixed design that we did for some special structures in Chennai. The speaker before me was from Turkey, and he presented an example where they had 10 months to do the concrete mixed design for a special structure. In my case, the client came to me a day before they wanted to start concreting. I told them, at least give me 28 days. Because first up, I need to hit the mix right then and there if I want a 28-day strength. So where is the question? Why can't we take more time for concrete mix design? It's a question for all you specifiers out there, all you structural engineers. Please remember, there's a lot more to concrete than just strength. And that's where we really need this aspect to be given more time. People really need more time to do an optimal design of the concrete to really get all these kinds of things that we are looking for, right? We can't just say we want strength, then anybody can do the design. No, not a problem. So, advantage obviously is that performance specifications addressing material it accounts for material complexity and does not pose limitations on so much content, so much slag, fly ash to use and so on. The durability is measured directly. We have a measurement for the durability instead of just saying that it relies on strength. Okay? There are some countries which have adopted approaches where durability is measured on structural panels that are cast alongside the actual structure and exposed to the same conditions. So when you are spending 200 crores to make a bridge, you can make, for 2 lakhs, you can make a small panel, right? Structural panel subjected to the same curing conditions that the bridge is subjected to, and take cores from that panel and measure durability on that. That will actually tell you what's exactly there in the structure. Instead of cubes that you bring to the lab and store in ideal conditions, that's only telling you a partial story. It's only for the construction process to go on that the cubes are made. It is not really reflecting the actual quality of the concrete in the structure. Okay? There's a better allocation of risk and responsibility. People are aware of what they are supposed to be doing in the entire process of concreting. There, of course, negatives are also there. At this current stage, there is lack of agreement on suitable tests. In concrete technology, everybody has a favorite test. So they want to use their test for everything. Okay. But how do you arrive at a consensus on what is the right test for a particular environment? Guidance is not very easily available as it is there in the prescriptive specifications. There it's very clear. You use this much only, right? You are bound by that rule. But here there's no guidance as to what to do if things don't work. Okay? Lack of understanding how to deal with failures. All that has to be brought in. And for that, I think the contractor and the specifier or the client or the PMC, they need to sit together and talk as to how this should be built in. Okay. Right. So again, I'll not focus on this. I'll just give you some examples of specs with durability requirements from North America, where there's a lot of projects where they have actually done this. We have also collaborated closely with South Africa, where they have been quite successful in very large road agency projects where they have undertaken work with the performance specifications. So this is just an example on bridges and all that, which use RCPT as a performance indicator and give you clear results with respect to what is expected on site. But what you need to also understand here is that it's not enough to actually give one limiting value for the durability indicator. It may be good for the lab, but in field, the variation in the concrete can be quite significant as opposed to the lab. So you have to accept that variability to some extent. You can't say that I want 99.99 as the value in the field also. You should say that, okay, I want 99.99 plus or minus a certain level of variability, right? The variability in durability characteristics is much greater than the variability in strength. One has to understand that also. When you test durability, even the codes that you refer to, they also give you a wide variation of the result that can actually come because of durability. So that has to be also accepted, and you design basically what is called an acceptance criteria. So just to give you a summary, performance approaches gives a rational means of doing durability design to ensure that your structure in the end is durable, not just the prescription leading to durability. It gives a quantitative meaning to service life. We can now figure out, yes, 50 years means what do I want in my concrete, right? and innovation in materials and technology is encouraged, I can use more supplementary materials. I can use multiple blends of supplementary materials to ensure that I get the right performance. Okay? And of course, as with any technology that needs to be implemented, there are several challenges in the way of successful implementation. I'm hoping that the experience gained in the local projects with the help of some of the things that we have explained in the book will help overcome these challenges to a large extent. So thank you. There's also a guideline available from ICI, Indian Concrete Institute, the Handbook on Concrete Durability, which is a slightly larger version of the same thing that we did. This one is specifically done for Kerala. We have identified specific exposure classifications in Kerala and worked according to that. But this Handbook on Concrete Durability is more of a general concept that we have explained as to how to do durability design of concrete. This is available from Indian Concrete Institute, so I'm sure that you should be able to procure from your local ICI chapters also. Thank you all very much.
Thank you, sir, for the presentation. I kindly invite Sri Rajiv, sir, Chief Architect PWD, to present a token of our appreciation to Professor Manu Santhanam and Professor Radhakrishnan Pillai. Sir, presenting memento to Professor Manu Santhanam. Thank you, sir. Presenting memento to Professor Radhakrishnan G. Pillai. Thank you, Rajiv, sir. NCRI 2022 is an important event that will etch the history of Kerala Highway Research Institute. As a matter of fact, this year, KHRI is completing its 50th year. So in this auspicious occasion, we are also celebrating our Golden Jubilee. On this occasion of our Golden Jubilee celebrations, we have with us a few of our former leaders, retired engineers who have served KHRI as joint directors. Their role in bringing KHRI to this level is substantial. They have strived to develop and instill values and culture in the institution and have guided numerous engineers to ensure the achievement of the organizational goals. I take this opportunity to invite Srimati Hygiene Albert Madam to present the mementos to our former leaders. I invite Sri V. Jayachandran sir to receive the memento. He has served as the Joint Director of KHRI during the period 1996-1998. Next, I invite Sri Uman Matthew to receive a token of gratitude. He has served the Joint Director of KHRI during the period 2004 to 2008 and 2009 to 2010. Thank you, sir. I invite Sri Santosh Kumar P. To receive the memento. He has served as the Joint Director of KHRI during the period 2008-2009. Next, I invite Sri Koshi John to receive the memento. He has served as the Joint Director of KHRI during the period 2010-2012. Next, I invite Sri Trivikraman B.S. to receive the memento. He has served as the Joint Director of KHRI during the period 2015-2016. I request all the former joint directors of KHRI present here to come to the stage to join us for a group photograph. Let us capture this memorable moment. I also invite our Chief Engineer Design to the dais. I also invite our Joint Director, Thomas Johnson, to the dais. I thank you all for accepting our invitation to grace this occasion and be part of our Golden Jubilee celebrations. We will definitely include this legendary photograph in our Diamond Jubilee souvenir. Thank you once again. Next is the inaugural keynote address on precasting and some other construction efficiency boosters by Professor N. Raghavan of IIT Madras. I invite you to the stage, sir. Professor N. Raghavan has exhibited multifaceted excellence with numerous innovative achievements in technical and managerial fronts over the decades. He is the Professor of Practice, BTCM, Department of Civil Engineering, and the Director, Institute for Lean Construction and Excellence.
So a very good morning to all of you. It's been a very interesting morning, and we have seen very important data about durability, resilience, sustainability, and so on. Can somebody help me with this? Oh, yeah. I think it's gone back. Yeah. Can you reset that thing, please? Okay, thanks. We talked about resilience and we talked about sustainability and so on. So in all these, we expect that construction to have been done properly. So construction actually, the parameter we can talk about, a single parameter to define your construction is the overall efficiency. So efficiency in terms of a number of parameters. For example, you have, sorry, I think it's going back and forth to get there. Okay, correct, yeah, sorry. So we talk about mainly four parameters for construction. We talk about the time, we talk about the cost, we talk about the quality and the safety. If all the four are done properly to the best of possible efficiency, possible limits, then we get good construction efficiency. So for resilience, for sustainability and so on, we need to have the maximum possible efficiency. And in my presentation here, we will see what are the various steps or aspects which impact efficiency and how to achieve the same. If you look at the United Nations Sustainability Development Goals, you will see that resilience is one of the key parameters. And for resilience, we have a number of other aspects as well. We look at that. And one of the fundamental steps of efficiency is the productivity. The productivity of construction labor, by which we are able to get the maximum possible output for the same input. If you compare the various disciplines, the top line, the blue line is manufacturing, and the lower line, the orange line, is actually construction. So if you look at the productivity increase of labor over the years, you will see that the construction labor has the least increase and the least impact. Whereas manufacturing labor, the productivity keeps on increasing by even a factor of about 3.6 compared to the construction labor. And that actually tells us a lot that construction is a discipline where it's difficult to increase the efficiency, but then we need to see how best it can be done. So my presentation, I will look at something called integrated engineering, combining design and construction. Then we look at the something called construction engineering, apart from simple design engineering, and some of the game changers in construction, and then some of the other methods we can look at, and then finally the conclusions. If you look at today's scenario, we have infrastructure as a key area of development. The government is spending even trillions of dollars for improving the infrastructure. So we have projects of today are highly complex, much more expensive than what we used to have in the earlier days, much larger, multi-dimensional, multi-theater. You know, you have construction happening in a number of different locations, fast, expensive, and above all, highly risk-prone. If you look at the construction scenario a few years back, some of the bigger companies who were there at that time, they are not there anymore because they did not pay attention to risk management. So construction actually is a risk-prone area, but in the overall sense, is very highly exciting. That's why we are all there, and we have seen a number of agencies coming into the field to do construction as efficiently as possible. I look at something called integrated approach to projects. We start from the functionality, what exactly we want for the project, the final completed project. Then the contract document defines the scope, the conditions under which it has to be done, and so on. Then we do a design, and then we don't look at the other aspects. So the other aspects are what defines something called construction engineering. The construction method, the materials to be used, the equipment to be used, and above all, the project management, which puts together all these ingredients to realize the project. So we need to look at all these aspects as a holistic approach and integrated manner to really realize construction as efficiently as possible. And then over the years, we have been seeing a number of developments, not only in construction, but in all aspects of human endeavor. The guiding parameter there is innovativeness. So all these we look at with integration, and we look at with innovation, and then we look at something called the life cycle approach. What Dr. Pillai and Dr. Manu Santanam talked about, we need to look at the overall durability and what is the life cycle we are able to get for the finished product, the finished project, and so on. So coming to these called the construction engineering, we normally don't look at it seriously at all. We need to look at the construction methods, the constructability studies, and then the selection appropriate use of the proper machinery, the 5 M's they call, the machinery, the materials, manpower, and then the management and money, of course. And today we have another aspect called digitalization and automation, which is becoming a very major factor in improving the quality of construction, the speed of construction, and so on. So the innovative thinking is something very badly required. That's what we need to look at seriously. The first one, methods. Many people, they look at a project, they do the design, and then it goes to the contractor. And the contractor has to figure out the method of how to realize the project. I will show you slides later of there are a number of ways in which you can do a project. And there could be one particular method, one particular way of doing it, which can be very efficient, which can add to the, the durability, sustainability, and so on also. And the method is a function of course, the design scheme and the site conditions. Without looking at the site, one can never make out a construction method. That's very important. And then what kind of equipment you're going to use, and what is the cost available to us for realizing the project. So here I am showing a few methods which we use for bridges. So we can have either cantilever construction, we can have in situ construction, precast cantilever construction. Today very popular for all the metros, precast segmental construction, And then we have whole span, precast and erected using floating equipment. And in India, we had done a project where we used a tidal power for erecting these heavy girders without the need for any expensive lifting devices. And then we have the incremental push launching, where the entire bridge is made on one bank and pushed across to the other end. Then we have cable stayed cantilever construction, suspension bridges, and so on. So there are a large number of methods for the same end. To make a bridge, you can have any of these methods, and we need to decide for a given site condition, for a given set of parameters, for the functional parameters, what is that method which is the most appropriate, the most efficient. That's where your skill comes in. That's where innovative skills are needed very badly. Here we have a very nice bridge, India's first precast segmental construction railway bridge in Arurkombalam in Kerala near Ernakulam. This was done in the 80s. I'm glad to say I was the designer for this bridge, and is still in service. And again, we need to look at, in this particular site, nothing else would have worked but precast segmental construction. And we had a very bold person, Mr. E. Sridharan, who was the chief engineer at that time, and he demanded that particular method of construction, and he got it. So it depends on the various parameters. For example, when it comes to buildings, we can have either in situ construction with climbing formwork and table formwork and so on, where you have a system approach to construction, or we can have precast concrete construction with slab and wall panels, or you can have assembly line techniques, what they're using in China by a company called broad construction. They divide the whole structure into a number of segments which are all made in the factory, properly tagged, and the whole scheme of assembly, everything is designed beforehand. And all of them are sent to flat at the site on flatbed trailers, and we get remarkable speeds of construction. For example, this 30-story building was done in just 15 days. So broad construction has figured out a way of how to do fast construction by going for off-site construction. You prefabricate the whole thing, have a very good system for releasing it, and then assemble it at the site as rapidly as possible. Of course, we also have the pre-engineered buildings. That's another method of doing buildings. Apart from this, you also have what is called the by one construction with monolithic concrete construction, pre-engineered buildings, like I said, or today we also have 3D volumetric construction with precast elements. And then when it comes to some other methods of construction, again, we can have earlier days, it used to take a long time for sinking our wells. Today we use precessing for sinking the wells. And then caissons for offshore structures, they can be precast on the shore, towed to the sea and sunk down, as was done in Bombay. Then a particular tunnel in Sweden was made with precast segmental construction. Undersea tunnel was made in a number of segments like this on the shore, towed to the side, sunk in position, and joined with the adjacent segments using the segmental the connection systems, by which the entire tunnel is totally watertight and is in good service even today. Then, of course, you have a number of slip forming systems for canal lining, for tunnels, and then you have pre-stressed concrete, the nuclear containments. The RE wall, the reinforced earth wall, was something not known, about 15, 20 years back, and today it's become the rigor for all retaining wall construction. So there are a number of different construction methods possible, which are appropriate for a given set of circumstances. That's where the construction engineering part comes in, knowing what method to use under the given circumstances in the best possible manner. Then machinery. Today's construction is highly mechanized and getting more and more automated. So we have a plethora of construction equipment, but which are quite expensive in the Indian context. So we need to get the best possible output from our equipment in terms of the productivity, and the equipment also has to be appropriate for the given set of circumstances. And to make the equipment work properly, we also need trained skilled labor. Today you go to any project manager and ask him what is your biggest bugbear, he will tell you lack of skilled labor. That's still one of the problems. But of course, we still have a lot of equipment of various types which are coming all over. We have foundation equipment, then we have the other kinds of equipment for various earth moving and so on. We have Strand Jacks. This is a very simple equipment which has not really seen its full potential in the construction scene. We can lift any amount of load by using Strand Jacks of appropriate strength, of proper strand diameter, and then you place it on top of a derrick like this, and you can lift any weight you want with multiple points of lifting. You don't need tandem lifts using big cranes, mobile cranes of 500 or 600 ton capacity. We can use Strand Jacks and realize the same thing quite well. And looking at the list of equipment, of course, there are the huge list of equipment which you can use for various applications. For example, tunnel boring machines, and then hole span launching systems, and then you have the robotic teledropper and micro tunneling for trenchless installation of utilities. In every major city, we see people coming and laying a road, and somebody will come just behind that and dig up the whole road for laying a utility. Whereas in many cities across our world, we have the trenchless installation of utilities, which doesn't disrupt the road or the traffic, but very efficient. So we need to develop this kind of techniques in our country also. And like I said, innovation is a very, very key parameter when you come to construction. So the next M, we have the methods, we have the material, machinery. Looking at materials, again, there are a lot of materials available today. If you look at simple concrete alone, there are a large number of different types of concrete. So we need to know again, what is that appropriate material for a given set of circumstances which can make your construction efficient. Today, I would like to highlight the 3D printed concrete and the self-compacting concrete as some of the major developments in the recent past. And another factor which is becoming very important with a lot of demolition and rebuilding going on, the construction and demolition waste, the C&D waste, they have to be properly utilized. And we need to re-extract the aggregates from these waste and reuse them for proper sustainability and resilience. So this is another major technique which is going on, and how to use waste materials for producing concrete of appropriate durability and strength. So materials again can be a major factor in controlling your cost and controlling your time as well. And next point, like I said, manpower, which is actually good skill trained manpower, is still scarce in our country. And even I think Kerala had skills training institute for training the labor to come up to the required experience and expertise. So there is something called productivity, which is not that well known in the construction industry. Productivity is simply output divided by input. It can apply to labor, it can apply to equipment, it can apply to even the capital, money capital we sink into the project. The output depends upon a number of parameters, but the efficiency is the most important thing, the overarching parameter by which we are able to get the maximum output for the given input. Today we have a number of different methods for measuring productivity of labor or equipment at the site. We have techniques like, for example, work sampling, foreman delay surveys, and value stream mapping as some of the tools by which you are able to measure the productivity at the sites of the labor, of the equipment and so on, and then identify and develop the methods for improving the same. So productivity, like I said earlier, compared to the manufacturing labor, the construction labor has the least productivity and the least capability for increasing it rapidly. Some of the reasons, we all know that construction labor is not permanent, is transient. They mainly come from agriculture and go back like that. So we need to identify the right type of people, train them properly, and then only we can get maximum improved productivity. And then when it comes to project management, the three main systems are planning for the project, then monitor to see that we are following the plan, and then taking control measures to make corrections whenever we are deviating. Very simply, these are the three major factors which we are doing in project management. And today we have a lot of software, starting from the earliest simple critical path method, going on to MSP and Primavera, and there is a ERP tool which again is of great use. Apart from the time management, we also need to do financial management to control the costs and the money inflow and outflow, and we need to look at also the contract management. That is something which is not that well known in the country. Many government departments, they believe in making a very, what they call a foolproof type of contract document, which doesn't give much leeway to the contractor. And then when the conditions are one-sided, not equitable to both the parties, when these conditions go for arbitration or for court hearings, they are rejected. So we need to have equitable contracts which are favorable to both the parties equally. They need to be developed right from the beginning. FIDIC is a great example, but then many people tend to dilute the FIDIC conditions by having severe particular conditions. That defeats the purpose. Many projects have got substantially delayed on account of a poor contract management approach. So I would suggest to the owners that we need to have proper contract formats. Today in lean construction management, I will talk about it later, we have something called integrated project delivery, IPD, wherein the owner, the consultant and the contractor can work together as a seamless team, sharing all the gains and pains to realize the project the most efficiently. So today, as you look at the innovative method of doing things, the contract management again is something which calls for good amount of innovation. And like I said earlier, risk management is something which we need to think about quite carefully. Of the various systems which are there in practice for managing the projects, the ERP, the Enterprise Resource Portal, that software is very, very important. Like you have SAP, Bond, Tactive, and L&T has its own homegrown system, and so on. All the various locations at which costs are incurred or money is being spent or productivity is being measured, all etc., they are all connected together by a single software system by which the management knows at any given time the status of the project, the financial health, the productivity health, the efficiency, and so on. That's all measured by the ERP system. So all the major contractors and major projects, they all have their own ERP systems, which are very essential and which integrate all the activities taking place in a number of different theaters. For example, you may have a supply chain management, you may have equipment coming from different places, and then the money coming in from the owner and getting spent. All these are properly linked in by a good ERP package. And coming to risk management, as I said earlier, many contracting companies have gone out of operations because they did not pay attention to risk management. It may not be very important for the owner, but for the contractor, the risk management is very essential. You need to identify what are the various risks and then classify them in terms of the frequency of occurrence and the severability of the, severance of the occurrence, and then plot them like this. So whatever comes in the top right-hand corner as the most serious nature and most frequent nature. So we need to address these risks which are coming in that quadrant so as to be able to have risk-less kind of operations. And today we have a number of methods of simulation for construction. Like for example, your metro construction, you have a casting yard with a number of formworks, and the segments are coming out in a particular sequence, and they are going to the various places where you are erecting with launching girders. And these locations are having different spans, different characteristics. So how do you plan your casting sequence, your stacking sequence where you are stacking the segments, and then getting to make sure that the right segments are coming to the theater of operation in the right possible manner. That's where the simulations come in. So for example, the transformer link Dr. Manu mentioned, we had done a simulation study from IIT Madras and developed an algorithm based on one of the software simulation software, how best to utilize your casting yard, your stacking yard, and the launching girders on the site, how to synchronize them properly for maximum efficiency and so on. So like I said again and again, construction today is a very challenging, very interesting kind of operation, and where we need to use, exercise maximum innovativeness to realize the best possible outputs. Some of the recent game changers which I have identified in construction, one is precasting or off-site fabrication, other is 3D printing, then we have BIM, building information modeling, and a whole lot of digitalization happening there, and then lean construction management. These are some of the game changers apart from many others which I have not listed. If you look at precasting, it's been happening for a number of years. The earlier days, all the industrial structures used to have a lot of precasting, but today we are also using them for a lot of buildings. There are basically three broad categories. We have the frame structure with columns and beams and possibly your T-sections or hollow core slabs and so on. And we have wall and roof panels, like you see here, a complete structure done with precast wall and roof panels, or you can have 3D volumetric system. And then you have a miscellaneous elements like staircase elements or compound walls and many other elements of buildings which are being precast and assembled. So what is the right system of precasting which you can use in your site? That depends again on your capabilities, the requirements in terms of time, cost, quality and durability and so on. But one major factor is the joints. Each manufacturer with his own system, unfortunately in the country, there are a number of different manufacturers using different systems of precasting. So today, if an architect or an engineer wants to put up a building using all precast elements, he has to go to only one particular manufacturer and adopt his systems, generally. So, and then again, we don't know exactly what kind of elements each manufacturer has. What are the standard dimensions they have? What are the load-bearing capacities? What is the durability? And so on. So what we lack today is a system of handbooks. We had developed one handbook with ICI in Chennai, and that's available to the market. But that again is not a very comprehensive handbook. We have, for example, the PCI, the Precast Concrete Institute of US, which has a very comprehensive handbook of precast concrete elements. So we need to define standard dimensions for our precast elements. Second thing is the tolerances. Irrespective of the method of joints which you have, unless you have the proper tolerances, the elements will not match properly. We have seen in sites horrible cases of large gaps after assembly. That's because the tolerances have not been specified properly or not achieved properly in the precasting factory. So we need to have complete range of integration right from the basic design of precast elements, the way you manufacture the elements, and then the way you transport them to the site and erect them and finally finish them. So the efficiency operations have to cover the entire spectrum of the steps, right from basic conceptualization till usage. Today we have large volumes of housing going on in the country. We have the PMA systems, Pradhan Mantri Awas Yojana systems, where a large number of buildings are coming up, and precast concrete method is one of the most suggested, most widely adopted systems. But there again, like I said, unless we are very careful about the basic concepts, the method of manufacturing, transportation to the site, in the Indian, the roads, kind of roads we have, and then utilizing them. And for precasting, the cost of transportation should be again nominal. We can't manufacture in Trivandrum and send it to Kashmir. It's too far and too expensive. So we are having a number of factories around the country, about 40-45 factories, but each adopting a different system. That's why we are calling for an integrated handbook which can specify the dimensions, load bearing characteristics, tolerances and so on, by which any architect or designer can design a building and then get the same executed or constructed at the site using precast elements. That's a big lacuna as of now, and that calls for crying attention. Here are two examples of very fast construction. A company called Katera in the Middle East, they did a building of 1,240 square feet in just 48 hours, 2 days, including all the finishes inside, ready to occupy kind of building. You have a picture there. And here India itself, L&T has done a building with 96 flats done in a matter of 96 days. Again using precast concrete, calling for complete integration. That's very, very important, right from conceptualization, structural designs, manufacturing, detailing all your joints and so on, the construction, erection. When you have so many elements coming to the site, one by one, they're coming to the site and they have to be stacked and then taken to the site for erection, you need to have a high degree of software integration by which you are able to keep track of every single piece which is coming, like a mechano set. If you know jigsaw puzzles, how do you get the jigsaw puzzle pieces onto your board and assemble them properly? The precast concrete construction is something like that. We need to keep track of all the elements, including the doubles and joint sealants and so on, at the right sequence, at the right location, in the right manner. That's where a lot of skill comes in, a lot of automation, planning and software usage also comes in. So today's precast concrete construction is not that simple as we used to think in the earlier days of industrialization. Then we have, apart from buildings, another area where we can really use precasting for the road pavements. We can have advantages you can see very well: fast construction, high quality of construction and durability, and then you have savings in materials if you are using pre-stressing, then eco-friendly, then easy to replace with the joints and so on, and then very good safety and user economy. You can see a number of places where precast concrete elements can be used for road pavements. If you look at the right-hand slide, where you are doing an in-situ road construction there with concrete, you have huge traffic pileups and other concomitant bad things happening there. But if you are using precast concrete elements with proper joints, doubles and so on, you can get much better speed, good durability also, and overall economy. But again, that requires a lot of careful planning, careful integration and good designs. And apart from the buildings and roads, we can also use precasting for road furniture, for all the cross drainage works and for retaining walls and for underpasses and so on. So here again, the innovativeness is what is badly required. For a given set of circumstances, what kind of precasting would be the most useful and how do we realize it in the site? Like I said, we need to have good design, good methods, good construction and overall good integration of all these aspects to realize the structure in the manner in which we want. And again, precasting is very highly mechanized. We have various kinds of formwork. We rarely use horizontal formwork where we cast a slab one over the other like that. We have battery formworks, and then we have automated systems of casting and curing. I have seen a factory in Krishnagiri of Katera where given the design goes to the factory in the form of a BIM model, building information modeling model, and then you have equipment automated fully, which place the shuttering, which cut the bar, which place the rebars, and then all the pockets and inserts required, and then the concrete is brought in by overhead gantries and placed in the mold accordingly. The skewed in the sense as quickly as possible, removed to the stacking yard. The entire thing is mechanized with minimum interference from labor. So that's why today automation and integration, they are the buzzwords which are very important for precasting. And here I think Dr. Manu would be more qualified than me to talk about 3D printed concrete. He's been one of the pioneers in the country. So 3D printing is the latest buzzword. We have this kind of nozzle which places concrete with the right kind of rheology and other characteristics. It should not spill, it should not crumble, it should stay stable, also gives the strength as quickly as possible. Then we have this kind of frameworks which are able to place your concrete. So you don't require form work, you don't require extensive scaffolding and so on, and the concrete is placed in a very rapid manner. And you have various kinds of structures which you see here, which are all made with 3D printed concrete. So again, imagination is the only limitation for the kinds of usage where you can put precast concrete, 3D printed concrete. Here there are more examples. So you can see very nice looking structures which are again made with 3D printed concrete. And I think here is one from IIT Madras, which is again been done very nicely. You can see that. So 3D printing has got many usages in the future. It can be used apart from building, even for your structures on the road, even possibly for your cross-drainage structures and so on. And this can be installed quickly, and the construction can be done very rapidly. But again, the basic conceptualization has to be done in an integrated manner. That's the key to the whole thing, integration from front to the end. That's very important. And building information modeling is something which has come into the market, which is come into usage in a very large manner in the recent past. You have a number of different software systems, and basically it is a parametric information storage. Every element in the model has got all the parameters associated with it stored right there. For example, if you click on a column element, it will tell you what the dimensions are, what are the concrete grade, the intended date of start, completion, cost, who's the agency doing that. All kinds of information can be stored in the model itself. And all the systems which are there in a building, like for example, your HVAC, plumbing, drainage, electricity, everything can be modeled in the same framework, by which you have total integration, and all clash detection is done upfront. Many times you see in a building, we have done the beams and columns and so on. Suddenly somebody comes and says, I need to pass my HVAC duct through a particular beam. Then we start breaking it. But in this BIM usage, all those things are, not at all coming in the picture. We are able to get the complete building, all the systems in the same framework, by which we are able to get total integration and total clash removal. And the advantages are good modeling, good for visualization. In the site, you can show to your foreman and the labor, this is the way the building is going to come up. They are able to visualize exactly how the various elements are getting dovetailed and how the structure is coming up. And along with that, you can also have BIM 4D, by which you are able to get the dates. You have your Primavera running on the left-hand side, and you have your building coming up. So you can see the timelines under which your various parts are coming up. And if you go to BIM 5D, you are able to also get the cost. How is my cost building up with my construction, and how is the time building up with my construction? So BIM is a great integrator, a very, very important concept in today's construction. You can do sequence studies, you can do simulations, what if analysis. You take out a particular the floor and puts another floor. The quantities are coming out immediately. So doing what if simulations are very, very easy. And above all, the same model can go at the end of construction to facilities management. The person who is running the structure or the project afterwards, he has got the complete project on his digital model. So it's much easier for him to do facilities management. Like I said, you have BIM 4D, you have BIM 5D, and then there are many more developments taking place. You have now gone up to BIM 8D with safety, quality and durability also getting built into it. It's a fabulous tool which can also be used for your infrastructure projects like metros or highways or other systems. Highways England, for example, are putting BIM to great use for the highway projects and road pavement construction and so on. So we start from the conceptualization stage, go on to design, analysis, design, documentation, construction, and then coming to facilities management, and even for dismantling the structure and removing it. So BIM can cover the entire cycle of a project's life, right from the conceptualization to its end. So great tool, but we need to use it properly. I know of many agencies who have invested seriously, very heavily into equipment and people, but they are not able to get the best output from that because they could never make up their minds on what exactly they wanted. What do you need BIM for? You want it only for a simple design, you want it for a facilities management, or for complete integration of construction. Unless you are able to make up your mind about the correct usage and invest in the right kind of equipment, software, and the people, you will not be able to get the best use of your money. So that's very important for BIM utilization. And then we have the leader, light implemented by this one, by you put an instrument there and you are able to get the complete digital map of the surroundings by having leader. And the same data can go into BIM for building up your model. So leader is a great tool which is coming to the market recently for doing rapid survey of the complete surroundings as quickly as possible and the most accurate manner. For highway construction, leader and BIM, software like MX, so they all can be integrated properly to get the best possible results. And over the years, we have seen construction management growing from the simple bar charts to CPM PERT to MS Project Primavera. We talked about earned value management. And today we have a new kid on the block, lean construction management. It's catching up all over the world, and Indian construction again is getting onto lean construction management. There's a body called ILCE, the Institute for Lean Construction Excellence, which is promoting lean construction in the country. So lean construction, basically it talks about identifying the value for the client, opposite of waste. If you go to any project site, you will see a lot of people idle, you will see a lot of equipment being idle and so on, because they had not been given the correct, instructions on what needs to be done. And construction is a matter of a lot of coordinations. There are a lot of coordinations between the supply chains, the design, the equipment, the materials, men and so on. All these need to be properly coordinated. And that's where conventional construction fails repeatedly. And if you look at, you ask any project manager, are you able to have 100% certainty in your predictions? We keep on giving budgets to the management who give to the public at large, various predictions on when the project will be completed, what will be the cost and so on. But we repeatedly fail in our predictions and certainty levels. That's where lean construction comes in, which is able to improve the predictability levels, certainty levels to a very major extent. So here we look at value for the client and totally remove anything which does not add value. Anything which does not add value is called waste. And then we look at the overall flow of work. We don't look at point speed, what happens today or tomorrow. We look at the overall scheme of things, how the construction flows from start to end, what is required at various stages and so on. And then we look at proper coordination between the various theaters of operation, value stream mappings. We keep on checking at the site which activity is value adding, which is not value adding at all, and which is not value adding but necessary. Like for example, farm work, which does not add value for the end product, but that is required. So we need to keep analyzing all these things and improve the client value. There's a concept called pull instead of push. That means every activity in the chain, it actually draws work from the previous activity only to the extent required. We don't keep on piling it up on the subsequent activities and getting into a logjam. So there are a number of concepts which I cannot explain in the very short time available, but lean construction is really a game changer in today's project management world. And if you look at simple thing like waste, lean identifies 8 different kinds of waste. You can look at the thing in later, but waste again is analyzed very seriously in lean project management sites and totally eliminated. That's a great thing to do for minimizing the cost and minimizing the time of construction. So some of the concepts are continuous improvement. Whatever we have been doing till yesterday, we are not happy with that. Today we want to do something better. And that's where innovativeness also comes in. A disgruntlement with the way things are happening now. We want to do something better. So that's a key concept in lean, continuous improvement. And why manufacturing is doing better than construction? Because you have a predictability in manufacturing. You look at manufacturing as a production system. Can we look at construction also as a production system with the same degree of predictability, certainty, and so on? Yes. That's where lean construction comes in, and it translates construction to production systems by which our predictability improves considerably. And then we have collaborative working. In many sites, we see various people operating, in watertight compartments. That will not work. Lean insists on the entire project as a collective enterprise. The people are recognized as the prime movers, and that's where people feel also happy in the overall sense. And there is something called the happiness quotient. How happy are your people in project sites? Are they really happy at the end of the day? The answer is no. Most projects they have seen around the world, that construction people tend to get a lot of anxiety levels. They feel uneasy because they are under stress all the time. How do we de-stress the people? How are we able to get the certainty levels to higher levels by which we are happy at the end of the day? That's lean construction. But I cannot define exactly what are the various steps by which lean is done. It's a kind of a culture, a way of thinking, not only as a collection of tools. So if you are able to get these concepts worked out properly in your site, then most likely you will succeed in practicing lean construction. In the earlier days, we have been doing construction in a particular way. You see people, working like this without proper equipment, carrying head loads, and here you see something passed on from bottom to the top through hand holding like this. We cannot do construction in this manner for all times to come. We need to change. So change can happen only if you are unhappy with the existing stage of things. That's where lean comes in. We are looking at continuous improvement all the time, and then we are looking at the change, the integration in an innovative manner. And some of the other innovative game changers, I will not go into too much detail. We have something called construction wearables. For example, you put a wristwatch, a smart wristwatch or a smart helmet, for example, which are able to track what a particular labor is doing all the time. How much time is he putting into productive work and how much time is going as waste. And if you are able to analyze it over a period of time, you are able to improve your efficiency. So you have sensors, you have 3D scanning like a LiDAR, and then you have something called big data. Like I said, with the ERP, you are able to integrate the entire system, all that is happening in a number of different theaters and so on. Artificial intelligence, Internet of Things. For example, your crane operating all the time or not, you put an IoT device there, you will sit in your office and know whether your tower crane is working to the best of ability or not. Machine learning, predictive analytics. So these are all buzzwords in the present day construction, where we are going into higher and higher levels of automation. And then we have modular construction like precasting, sustainability, reducing carbon emissions by being more productive. And then we have the building information modeling, and we also are able to use virtual reality and augmented reality in project sites. In the West, for example, the foremen are going into a site with a tablet with the BIM model loaded onto it, and they're able to look at the project and look at the BIM model and see the variances in terms of time, in terms of dimensions and so on, and able to come to decision points quickly. And then we have the connected construction. Everybody at the site can load information onto the big data using a mobile, for example, and able to get the bigger picture. The head office need not actually get involved at the site so much, with data coming in from all these areas of inputs, and we're able to get the big picture built up in an automated manner, in a very correct, realistic manner. So there are actually, we are thinking, drones again are another way in which we are able to use construction. We are able to visualize, we are able to check, we are even able to deliver components to difficult access locations. You can use a drone to pick up something from the side, from the ground, and hand over to something where inaccessible areas and so on. So there are a number of game changers which are coming around in the construction scenario today, where with our innovativeness, we can improve the efficiency substantially. So this is what came up in the last, I think, one of the international forums, where we are heading for the future of construction. So whatever I been telling you in the recent, in the last few minutes, it's all put in a pictorial manner here, and we are able to see that construction is heading to smarter and smarter ways of expressing itself. No more are the days, where some engineer used to go to the site, shout at the labor and get things done. Today things are done in a much smarter way, much cleaner way, and with much more predictability and certainty. So we have more control on the 4 parameters: time, cost, quality and safety. And then we are going towards better sustainability and better resilience in the longer run. That's very important. So good construction is very complex, multidisciplinary, and requires much more than simple pouring of concrete. And there is a need for many possibilities of innovative working and creative working. We have seen a number of efficiency boosters. The fundamental thing I would say is integrated engineering, right from conceptualization to the completion. So functional conceptualizing, structural design, construction engineering, then the methods, machinery and so on, and good project management above all, and facilitating contract management. And digitalization is a very, very important thing happening in the construction nowadays. Automation with various parameters like this, and then overarching innovative outlook backed up by good R&D. So R&D is again very important for major construction companies, where they are able to improve the way they are working from day to day. This is a picture of the Chenab Bridge, which was completed very recently. All the, most of the parameters I have been talking about, the methods I have been talking about, were all used in this structure. They had gone for a Tekla model, BIM model, by which they were able to track all the individual components coming up with this structure, and very difficult logistics approach and so on. But with all the difficulties, they were able to complete this structure in the more or less the required time, quality and so on. And with that I conclude. Thank you very much.
Thank you, sir. Dear audience, now we have a doubt clearance session. If you have any doubt regarding the presentation, you may please raise your hands.
It has been a wonderful session, but only thing is people like me, being 85-year-old, absorption level is very low. But still, I have worked in the field for 60 years, 65 years as a civil engineer. So I have some comments to make on the professorial or academic this thing presented. Now, one thing is corrosion you are talking about. I wish that also had dealt with corrosion phenomena. What is the free lime available in the cement or concrete after the hydration process, and how does it matter? And what is the carbonic acid, which again, acting with the lime, it leaves white patches. I have done a number of structures, very intricate structures for Department of Space at the coastal region, so I know what, I mean, these are very important aspects. And fortunately, one structure done in Sriharikota, that is in Andhra Pradesh, what is known as solid motor testing facility, which has got a twin column, 19-meter clear span, portal frame, having 200-ton capacity crane moving at 30-meter height to take the element that is a solid motor. So what I'm trying to tell is, this was done in '83. We had real worries what is going to happen about this thing, because those times, 40 years back, it was not that easy. There was no cast or prefabricated system and so much of machinery. But to tell you frankly, it has done the job and it is still working, and I understand there are no clear, it is just not at the coast. So there what I wanted to say is this corrosion phenomena, anode cathode situation, oxygen presence, and then carrier, that is wet atmosphere. All these factors come into play. Then with regard to free lime in the concrete after hydration, if you use slag furnace, this thing, as well as the other, what is that? Fly ash. It reduces the lime requirement while manufacturing the cement. That is how it is reduced. So free lime presence is much reduced on account of that. So it is ideal. In fact, this thing what we used was, fly ash cement. Okay, that helped. But that is only one part. The other part is, unless the engineers concerned or supervisors really put their attention to see each and every operation, because these are all in situ operations. Okay, so their attitude to involve very actively and closely at every stage is very important. I wish that aspect also was stressed a little more. See, anything you design and your drawing board, everything will be fine and the software, everything. But finally, now for instance, you said, someone said the measurement of this thing, cover. It's not that simple. In the sense, suppose you measure and find that the cover is not adequate at one place. What do you do? Slab is done. So there are very, very intricate situations developing on account of that. So the most important thing is you must ensure cover block in position. Okay. So for that there are methods. It's not that very difficult. Only thing is the engineers will have to play their part. Then you talked about a cover block getting displaced and things like that. It is, but we use wooden benches so that people carry concrete or whatever it be, vibrator, they move on this thing so that they don't disturb this thing. But then again something will happen, but that is for the engineer to worry about it. Okay. So now the cover block manufacturing, now fortunately it is being manufactured by various firms, so there is no much issue. But earlier it used to be cast at site. Hardly anyone bothered whether it is properly cured or the mix used is adequate. Most often, if engineers don't bother, what happens is it acts like a blotting paper. It's a cancer in the body of the concrete. Then the corrosion phenomena set. Okay. So these are the major things. So engineers' attitude and their involvement, active involvement, is a must. Otherwise, nothing much is going to happen, even with all these things. Now, other point I wanted to say, sorry, I will not take much time.
So if I can just, yeah, I think I totally agree with you. Ultimately, the success of a project is definitely dependent on the engineer at site who's actually responsible for the structure.
I don't say exclusively,
Yeah.
but it
Yeah,
is
yeah.
a major factor.
Definitely.
And for that, in fact, to tell you frankly, when you said this, yesterday I released a book, Construction Management, in the Institute of Engineers, written by me. It deals with these things.
Sure.
Very, very, very brief manner. Yeah. But then, these are things hardly anyone bothers.
Yeah. No, I think you also mentioned the fact that what if the cover is not met? I think those are the kinds of questions that I was also raising, that these performance specs need to be prior to the construction worked out. People get a clear sense of what needs to be achieved. And I think we define this very clearly in the beginning.
One more aspect when you mentioned that, just by putting in a contract one condition that this is measurable and if it is found as a thing, it is not going to solve.
No, that's what. We have to identify what to do if the...
Yeah. Caution the contractor.
Yeah.
Because he will be a sufferer.
Correct. No, but the contractor has to be aware that, yes, correct. They need to deliver a particular quality with a certain level of tolerance that is specified.
They say cement manufacturer, though everything is ISO, what is the guarantee that each bag that comes, it meets the quality? So you will have to necessarily do the test when each consignment is received.
Correct.
I have ended up in a very serious issue in this particular building which I mentioned, 200 ton, South Korean cement was shipped to Madras, and we arranged to collect it directly from the thing to Sriharikota. But unfortunately, when the Q test was taken, we could not, because the time frame was very important, time management. So we tested at the 7th day and found it is weak. It is not meeting, but marginally. We can't wait for 28 days. We are losing 28 days work at site. It's a huge facility. So we immediately invited SCRC Madras, and after taking the Qs, accelerated curing and got it tested in 24 hours, and then the result was not acceptable. Whatever columns what we had done, it is a terrible this. Okay, we had to dismantle manually. There is no other easy methods. Okay, so engineers, this thing, and they cannot have control over the factory products so much. But then these are the realities of the conditions. Okay, thank you.
Thank you.
Yes.
Here is where I talked about the construction engineering. The Arulkombalam bridge I showed there, about 3.5 decades, still there is no corrosion in corrosive atmosphere. Because the approving authority at that time, when the design was made, he made the consultant develop a complete construction method note, detailed step by step. What are the various things required for making that? See, precast segmental construction for a railway bridge was unthinkable at that time, except, by a person like the Sridharan who had immense courage for doing that. So how was a bridge constructed by a contractor who had done a bridge for the first time? So the integration is very important, and making a construction engineering methodology note, that again was very important, making step by step, and then identifying the pain points, what can go wrong, and suggesting methods for alleviating or avoiding such pain points. So these are all, methods of construction engineering also to be done if you want really good project to be realized.
I just want to add, when you told about this cover depth issue and what your final word was, what do we do? I would suggest something on that. I didn't put it on the slide. So we now tell, like, can we have a person whose title will be 3 C's? Okay? Or designation on site, it's 3 C's. 1 C is for ensuring cover depth. Number 2, second C is for ensuring compaction of the concrete. And third C is for ensuring curing of the concrete.
What about the concrete cover block itself?
No, it's a cover depth.
It's the quality of that.
No, that's his.
Hardly anyone bothered.
No, that is that's we mentioned already that. Okay, so now if we have this person, but the supervisor of that person should not give any other job to this engineer, this person. So this is the difficult thing which we have to really think. We want everything, but we are not able to change, or it's very difficult to make changes. So can we have this 3 C's person at the construction site? And exclusively for these 3 jobs, because these are very crucial things. And if we can have that, I think maybe some changes. And if the cover depth achieved is not adequate, in one project you have to do something about it. Then the next project you will not have that problem. But can we actually do it? It's a very hard question. So, but this is the forum where we have to raise these questions and we have to start thinking about it. We can't be very nice in talking all the time. So if we take care about the structures, I think we have to start making such harsh decisions at one time, so that in future projects things will change. I would just leave it there.
My question is to Dr. Pillai. Is there any other method other than increasing the cover to protect the rebars from deterioration by corrosion?
Yeah, that's why we don't have to increase the cover to give that protection. If we use a better quality concrete with the same cover, or even probably less than what it is possible to get that protection required. So it's not about the thickness of the cover, it's about what do you actually put in that cover concrete. So you can... That's possible. So like materials like fly ash, slag, rice ash, all these can actually give that protection.
Yeah, so in a chloride environment, for instance, like a coastal environment, using concrete with fly ash or slag is going to be definitely beneficial with respect to corrosion resistance. That means you're increasing the quality of the cover concrete. But the important part also to address is the construction aspect, because quality may be good. What if you have cracking? There's the entire concept of your concrete quality is gone. So avoidance of cracking also is very important. So that's the fourth C I would like to add. Four C's person we need. Maybe more C's will come, but yeah.
It's regarding again. It's again regarding the corrosion in coastal areas, especially regard to bridges. So during the presentation, it was mentioned that the addition of the fly ash in the manufacture of cement, that is pozzolana cement, it will reduce the chances of corrosion considerably. So as we know, we were using for embankment construction. I'm a geotechnical man. Embankment construction we were using because it was obligatory to take from the thermal stations in various parts of India within 100 kilometers. So we didn't have to look at the chemistry of the thing. We are only looking at the particle size. So now, as I understand, it has a lot of chemistry inside. So I want to know whether the fly ash produced from any cement factories in any part of India can help us to reduce the corrosion, or can we in the contract document itself can say, you are a contractor, you are free to procure Portland pozzolana cement of such as its grade or something from anywhere, so that it will help in reducing the corrosion chances.
Yeah, I think the question is, can we include in the contract specifications? Okay.
Tamil Nadu or whether it is from the northern part of India. I understand that the properties may be, chemistry may be different, or the chemical properties may be different of this fly ash. So will it have any adverse effect if we don't specify that it should be of this much property? The fly ash you are using, it should have this much, otherwise it may be detrimental for the concrete. Whether such chances exist, that is what I want to know.
Sir, actually fly ash properties have been very well defined in the fly ash specification. So it has to meet a certain requirement chemically and physically, in terms of particle size, in terms of silica content, in terms of its reactivity also. It needs to meet up a certain level of performance. So as long as those are satisfied, any fly ash should be capable of getting used. But of course, you won't want to bring fly ash from very far away, because transportation costs will be too much, and then it's not really going to be beneficial. PPC. Yes, sir.
PPC produced in Tamil Nadu or produced in
Exactly, sir. PPC is a controlled product, sir. It has cement in combination with fly ash, and the fly ash quality is controlled in PPC. Definitely, PPC is easy to use and easily available everywhere. Certainly, sir. And Portland slag cement also. PSC, same thing.
I want to tell this story here, which we just did actually, whatever you were asking. So I think Shankar and the KHRA team, we actually, and engineer Anu, I would like to mention his name here. He was very instrumental in getting this done. In the Valiyadikal bridge in Kollam, I don't remember how many spans, but initial spans were done with OPC. And then we kind of suggested this use of supplementary cementitious materials. Of course, as usual, there were resistances in changing, but we were able to do it. And I think the center span is PSC or the approach? one who did it. So
Yeah, it's a center span and the approach span. We did it with PSC. It was not side blended, but we purchased Bharati slag cement. So quality was good. So initially we thought of blending the cement with slag, but later on we had a problem with the, we actually doubted whether the quality will be ensured. So we suggested that we'll go with cement. Again, we had problem with the mixed design. We tried with different cement, but finally we got Bharati cement. Okay, thank you.
No, this was done, and you need courage to change or implement such things on site when it's not given in contract document, like what Professor Manu was saying. There are like this small footprint written, fine print, where you can actually use your knowledge to make good changes. So this was done, and then I would also like to mention, we actually did a little bit more study on the same bridge. We took core specimens from the actual bridge, from the side elements, so that there is no structural related issues. And then we did some study in KHRI lab here, and now we are writing a paper on that, journal paper on the service life difference because of the use of the PSC and OPC. And you want to know how much difference is there? A significant difference. What we are finding is, if the OPC elements are going to be, let's say, 30 years, the slag elements or the spans with slag, at least the center span will stay there for much longer than the earlier spans which were made with OPC system. Much longer, and we are getting like close to 90 years of service life estimated as compared to about 30 years for the other spans. But of course, these are, analytical studies. The point is not to look at the absolute number of the service life, but to look at the difference which we get. So definitely it's a, go-to option, let's forget about this 100% OPC concrete. If you can take away that one concept from today's discussion, I think job is done. This 100% OPC is really killing us when we talk about very long service life. We have to go with use of fly ash and slag, and preferably PPC and PSC, so that we don't have to worry about this variations in the initial stages of implementation. Maybe after a few years, we will gain enough expertise in using those materials, and at that stage, we can go with on-site blending. But otherwise, there is not at all any issue. It's just a myth that these materials are impure or waste. But waste can also be good. Somebody else's waste may be good for us. That's exactly what it is. It's power plants and steel plants waste. And let's use it in construction. There's no harm at all. Thank you.
Thank you, sir. Now we have one last question before ending the doubt clearance session.
So just a quick comment for all three speakers over here. With regards to checking, whether it's cover or rebar on the side, very quickly I've seen, introduction of BIM where it is being used to check rebar. So you have a BIM model and all you're doing is scanning it over your slab, and it's able to check whether your rebar is matching what is there in the construction documents, and that's being used. And same with respect to use of drones. Just right before concrete is being poured, drones are being used to really image the rebars and put it into a facilities management program, which is something that could be done so that when changes are needed later on, you can go back to the software and check your exact locations rather than doing scanning later on. And thirdly, even for your cover, imaging can be used through use of drones, and pinpointing can be done of areas that are lacking in cover, etc., immediately before pouring, so that they can be really corrected at that point of time. So technology is evolving, and we need to have this multidisciplinary education that needs to happen at these institutes. So civil engineer need not just be a civil engineer. He can have courses in imaging and computer engineering, electrical engineering, wherein new areas need to really come up so that they can be useful in our everyday construction. Thank you.
That's why I used to tell that construction is no more a low-tech kind of field. Construction is becoming more and more a high-tech field, deserving a lot of recognition and good work for innovation and progress.
Thank you. As a token of appreciation, we would like to present a memento to Professor N. Raghavan of IIT Madras. I kindly invite Srimati Lizzie's Chief Engineer, KSTP, to present the memento. Thank you, sir. Thank you, ma'am. Now, I would like to request Sri Rakesh J. Pillai, IIT Palakkad, to offer felicitations.
Hello. Yeah. Good afternoon, all. So I am here representing IIT Palakkad, the delegation from IIT Palakkad, including faculty members and research scholars. So the idea of NCRI originated mainly after the 2018 floods in Kerala. Then the society as well as the engineering community understood the importance of resilience in the design as well as construction activities. And the gap between academics and industry is well known for a long time. And KHRI took a very good decision to reduce that gap, and they took a very good initiative of a center of excellence, and they have a chair at IIT Palakkad. As a part of that center of excellence, we will be continuously doing many seminars, conferences, workshops, etc. So the first edition of NCRI was planned in 2020, but that time we had the COVID and we had to make everything online. It didn't go. The requirement is actually the interaction between the academics and the industry. So this time we planned to have it in a fully offline mode first, but later we had to move to hybrid mode again due to some problems which shows that resilience is really important. So now we are actually starting this NCRI 2022. Where we added 2 more topics. In 2020, actually, the topics included resilience in pavements, resilience in transportation systems, in structures, as well as geotechnics. This year, we planned 2 more topics, mainly resilience in project delivery, as well as climate resilience. So these 2 topics were added, and on these topics, we asked for abstracts throughout the country, and we contacted many experts throughout the country for their guidance in the technical aspects as well as for giving their expertise during the conference. So many of them have come here for the keynote lectures and other invited talks. And we received about 75 abstracts, and after peer review, about 47 papers were accepted for the proceedings, and 33 of them are being presented during this conference. The sessions will be conducted tomorrow. So I hope the starting of the blending between the industry and academia will start during these sessions. So I request all the PWD engineers to be very well present during these sessions and have very good discussions. So the problems really you are facing, and resilience is actually should be included in all the construction activities which is going to be happen, and that is very, very important for Kerala. So I hope it will be a very fruitful discussion during this conference, and I welcome all of you for these discussions and all the sessions. Thank you.
Thank you, sir. Now I invite the Joint Director of KHRI, Sri Thomas John, to deliver the vote of thanks.
Ladies and gentlemen, good afternoon to all. It's my privilege to propose a vote of thanks to all dignitaries assembled here on behalf of NCRI 2022 team. We are really grateful to our Honorable Minister for Public Works, Sri P.A. Mohammad Riaz, for his presence and his words of encouragement altogether. And not only for the inauguration ceremony, Honorable Minister was kind enough to support all our activities of KHRI, not only for NCRI, all the activities of KHRI, and for the Center of Excellence activities altogether. It was a great source of encouragement to us. I would like to thank our Honorable Secretary, Sri Ajit Kumar IAS. Who is a very proactive person for us for almost all activities. He's an encouraging factor behind us. Behind all the responsibilities, and his presence has graced this occasion, and we are really thankful for his presence, and we express our gratitude. And all the dignitaries assembled here accepting our invitation, we are really thankful to you all, especially Professor Manu Sandhanam, Dean ICSR, and Professor Radhakrishna G. Pillai of IIT Madras, both being the backbone of our great task of developing performance-based specifications for concrete structures and delivering the messages. We are really thankful to you all, sir. Special thanks to Professor N. Raghavan for the inaugural keynote address and clarification of the doubts and all the sessions, all the support. Special thanks to Professor Dr. Raghavan, sir. And we are really grateful for almost all chief engineers who are present here with their presence and all the support, especially our PWD Chief Engineer Design, Hygiene Ma'am, giving the proper regular support for us and encouraging us. We wholeheartedly thank all the designated invitees present here from various academic institutions, other departments, many senior even retired officers, and practicing professionals, keynote speakers, and delegates. At the special thanks for team IIT Palakkad, actually, irrespective of the many unexpected rescheduling and many inconvenience, they worked day and night to make this program, this conference, a great success to this level. And under the team leadership of Dr. Rajesh Pillai, and we express our great gratitude to all of the team Palakkad IIT team. And being the Golden Jubilee year, and our former leaders were here, and we are thankful for your presence because of your hard work, we are in this position now after the 50 years of the existence of KHRI. So, and I no need to thank, but my colleagues from PWD and Team KHRI who worked day and night to make this event a memorable event. And thank you very much for my colleagues and for every arrangement. Those who help for every arrangement, we are really thankful. Thank you very much. Thank you all.
Thank you, sir. Dear all, now we will have a lunch break and we can resume the next session at 2:15 p.m. Thank you. Also, please note that the copy of the souvenir is available at the registration desk and you may collect it from there. Dr. Satish Jain, PESE, Managing Director, UPHC India Private Limited, and Satish Jain Consultancy Engineers Private Limited.
Yeah, right here. Sure, absolutely.
Good afternoon, everyone. Hope all of you had a nice lunch. It's great to be here. Thank you very much, KHRI, for putting together this great session, 2-day session. Let's go back over here. So, yes, we're going to talk about ultra high performance concrete, but basically we're going to talk about something that was just clicking in my mind as I was thinking about a topic as to how exactly we can, safeguard the money for the future. The reason I talk about it is the tremendous amount of construction that's going around the country today and what's going to happen tomorrow. How are we going to make money available for tomorrow's new structure, tomorrow's repair and maintenance? And, working in the field of ultra high performance concrete, in fact, we do have a company, UHPC India Private Limited, and we have been working in this area very closely, and I think this is one of the areas that can really lead to something. So here are my thoughts for today. Let's just put it this way, and I'm going to just expose those thoughts over as we talk about it. So as the first lecture today started, I'm going to probably start in a similar fashion with a photograph, right? So here's a little pic taken just a week to 10 days back in Mumbai. Off of Mumbai, this is a roadway that carries extensive transport from the port to various parts of the country. And the road is tremendously dilapidated. If you look at the slabs from the top, you can literally see rebar exposed, several layers of, bitumen already put over the top of it, at a variety of places, and even that's, sagging. And I don't know if that is clear from your end or not, but a lot of cracks in the slab of the, in the bottom, bottom part of the slab. Oops, let's move forward, trying to get adjusted to this thing. And, a lot of patchwork being done on that bridge with some M80 grout that was put in. Also, variety of repair work being done. This is with, carbon fiber over here, another contractor coming in at a later stage, putting these cross diaphragms and, something to support the slab, another contractor coming in and putting metal deck over. And I saw probably 1 or 2 more different kind of, repair works that had gone within couple of spans. So you can imagine every time something happens, there's a contractor who's ready to come in and apply his own, repair work. That's how this thing is going around. I don't know if you will be able to see this or not, but that's another flyover. Believe it or not, it's not even 10 years old, and it has all kind of shear cracks at both ends. Imagine shear cracks. They are not even flexural cracks. It has shear cracks all over. Now, that shouldn't happen on a PSC girder, but that's the state. So it's not necessarily all contractors' fault. Sometimes, we have bad construction, but there are times when even the designs are pretty low grade, and that is what we are seeing. I don't know why, because the specs are too tight, but sometimes these kind of things go on even after peer reviews. Another project, this is in Andhra Pradesh, and this is seeing, bad amount of, the things have just gone wrong all over, all the way from the girders to the slabs. So what are we going to do about it? That's costing us a lot of money. I mean, look at it. Look at it over here. We build a bridge, a few years down, it degrades, and then you rebuild it. It degrades again, rebuild it, degrades again, and that's what keeps on happening. So what are we really doing about it? And maintenance, repair, upgradation, maybe live loads are coming in, so there's more upgradation. So we just keep spending money. One more over here. See, if you do that, this is an example that I just took out of the National Cooperative Highway Research Program. If you look over here, so we keep repairing, we spend money on repair, new renewals, and then over the life cycle, we just keep spending money. To give you a very, very simple outlook,
took this out of a Federal Highway Administration from the US. I took this out of a report of theirs. And if you look at the figures, these are typical bridges, a slab bridge, a pre-stressed concrete, box beam, and these are, these are examples of a life cycle cost over a span of 30 feet, so not too long, but, small bridges. And look at it. Initial cost, some $51,000. Life cycle cost analyses, $133,000. So over 2.5 times. Nothing too different between a $75,000, nothing too different between a $75,000 cost versus a life cycle cost of $170,000. Same thing down below. So we are really talking of a cost between 1 to 3 times over the life cycle of a bridge. Isn't that amazing? I mean, I don't know if somebody can here help me out. What is the amount of budget in Kerala for new bridges every year? I don't know if the Kerala Highway Administration can help me out with that number, but it'd be great to know. But let's say X amount of number. That means over the life cycle, we are probably going to spend 2 to 3x for that one particular bridge that we built. Okay. So bottom line, you need continuous flow of funds to maintain your bridges. And where do these funds come from? I mean, yes, the state government can provide that fund, the central government can provide the fund, but the fund really has to come from the public taxes, right? It has to come from the cess on the petrol, the diesel. It has to, come from other forms, maybe from all the imports, exports that happen. And we are spending the public money into repairs. A whole lot of repairs. Agreed, some amount of repairs is required, but we are just splurging money on repairs that could be used for all other kind of new construction, new infrastructure development, or all other kind of programs that can help to develop our country. Give you one more perspective over here. So, like I said, the country has booming infrastructure right now, and this is just a report of the Ministry of Road Transport, and Highways. So from the north, this doesn't have anything to do with the state government numbers, but look at that figure, staggering. The phase 1 of the Bharatmala Pariyojana that's going on right now has almost about rupees 6.3 lakh crores committed. Across economic corridors, other corridors, etc., and there's some other monies as well, but at least the infrastructure ways, new construction itself is asking for 5.35 lakh crore rupees. That's a staggering amount of money, again, to speak of. Let's look at the annual budget of the North. FY20, 78,000 crores. FY21, 101,000 crores. FY22, that has grown to 118,000 crores. And this, of course, includes roads, bridges, some other infrastructure, money given to NHAI from the north, and also probably includes a little bit, 5 to 10,000 crore rupees as part of the revenue expenditure of the north. Let us just take a small figure out of that, just 15% of that figure of 118,000 crore rupees, that amounts to 17 or close to 18,000 CR. That's for 1 year, right? And that is just the central government. It is not even the state governments, right? It's just the north. I just showed you some figures in the back slides. We need about 1 to 3 times that amount of money to maintain these bridges. So if those are the new bridges that we are spending on, you almost need 36,000 crore rupees for every year of construction, and that money is going to grow. Next year, that $118,000 might grow to $140,000 and then 160, maybe 200 in 3 to 4 years, given the amount of construction that's going around in the country, where's that money going to come from? That's very, very important to understand. And that's where, this early morning's presentation on durability is so very important. There is nothing like durability. And that's where we are going to save the money for the future. And so here was my thought. When I talk about UHPC, I was thinking, can we have a material that can give a one-time solution in whatever manner it is used? Can we have that? Whether you do it for repair, and once repaired, it should work for the service life of the structure, 75 to 100 years, 120 years as may be required for that particular structure. Or if we even utilize that material right from the start, then you don't even have to think about spending that amount of money for the future. Can we do that? And that's where the answer lies in a maintenance-free service life. We'll talk about ultra-high performance concrete a little bit now. So when I talk about this material, last 1 year it has gained quite a bit of momentum in the country, and a lot of educational institutions, research institutions are picking it up. There's a lot of talk in the private sector with regards to the use of ultra high performance concrete now. As a sudden buzz in the last 1 year. So it's important for us to learn what it is all about. Very quickly, it's more or less a powder form material. It's more like a mortar in general. Okay, so we are talking of ultra high performance, right? We're not just talking of some ultra high strength concrete. Strength is secondary for us. We're talking of performance, and it's a material that is really composed of, all high grade cementitious elements in there. Plus, you have a good quantity of microfine steel fibers. When I say good quantity, about 2% by volume, that's quite a bit, about 156 kgs a cubic meter. And these are as fine as 0.2 mm by 13 mm length, right? And having a high tensile strength of 2800 MPa. But that's what really gives this ultra high performance concrete both its mechanical and durability properties. Really good composition, tight particle packing of your cementitious material along with the sand, and then your steel fiber gives it the tensile properties. And at the end of the day, you can have a very nice flowing UHPC that can be filled up to take any shape of any kind. So very quickly here, we are talking of strengths in the range of, I guess the top is, can't see the top over here in the slide, but we are talking of strengths in the range of 150 to 250 MPa, anywhere in that range. But let's keep the compression strength aside. Again, this is a talk more on the resiliency of the structures, the longevity of the structures. Durability is really important. Look at the tensile properties. Even that is very good, extremely good. And you get post-peak ductility. Very high elastic modulus, about 50 GPa, 50,000 MPa, and very low creep. So while in certain parts of the world, it has been started, like girders are being made. In India also, a lot of emphasis is being put on girders right at the moment. But we'll talk about what actually should be the purpose of UHPC in the country and where it should actually move forward. Very high shear though, let me not forget this before I move forward. Very high shear strength. So if you take UHP FRC just by itself, it should be able to give you about 10 MPa design strength, which is very high compared to the 4 MPa that you use just for concrete plus the rebar as a limiting factor. So that itself helps in a variety of ways. This is a slide that I actually wanted to come to, because when we talk of durability, if you take normal concrete, let me just go back. If you just take normal concrete, and if you put it as a unit factor over there, then if you take high performance concrete, look at the durability factors, oxygen permeability or chloride penetration, water permeability or reinforcement corrosion rates, any of those factors, look at where UHPC is in comparison to normal and high strength concrete. That means now we're talking of a material that's extremely durable. We're not talking of a material that's just 2 times durable than concrete. We're probably talking of a material which is about, 40, 50, 100 times more durable than concrete in the long term. This is what needs to be utilized in our country to make sure that we are moving in the right direction and saving in the right places. And therefore, we call UHPC as a material which is between concrete and steel. Even your elements can be 50% lighter, negligible rebar, 100-year maintenance-free life period. We already spoke about it. Can we just clear that off? Yeah, thank you. And very high wear and impact resistance as well. So wear and tear is very important. As far as that mechanical property of wear and tear, very important when it comes to bridges. And one thing that you cannot see at the bottom, and I'll tell you, is typical rapid gain of strength. So yeah, we can talk about, heat of hydration and everything, but even when you keep low heat of hydration in UHPC, you can still see that after 24 hours, you can get about 60 MPa. After 3 days, you can get about 100 MPa strength. And that will really lead, if you got to move into accelerated bridge construction or accelerated repairs, this is one of the materials. So you can just put it on there, whatever you want to do with your, bridge repair or new deck construction, and you can open up your traffic pretty fast. Let's try this. Next, please. Okay, so I just want to show you a very quick video of here, UHPC flow, and this is without any tamping. This is how good a UHPC typically flows. All right, so it's a small flow cone, and there are ASTM documents available for a small flow cone, flow test. ASTM C1856, which gives the recommendations on the same, and you would probably want to see somewhere close to about 200 mm or so of flow, or a little bit over that, about 240 at max. Even 250 is fine sometimes for certain purposes. Do not want to go 300 mm on a flow. It could lead to segregation, but somewhere about between 180, 190 and 250 is a pretty good number for a good flow test. Also, this is a quick video from a project site wherein UHPC is flowing out of a transit mixer, and you can see that it's just flowing inside a girder as easy as it can. And believe it or not, it has those 2% fibers in it. So even with that kind of fiber content, there is no amount of lumping or no lumping, etc., that you will find. And UHPC can really go and fill places where you want it to. In fact, in today's date and time, there are all kind of UHPCs that have started coming into the world market. And one of them, which is really going to change the way of repairs, is your shotcreting, with UHPC, because that's where you can repair from the bottom really well without having to put any kind of formwork. So we'll see those kind of things coming in. But again, harping a little bit more about the durability properties, just for quick technical comparisons. A normal strength concrete might have anywhere from 2500 to 400 coulombs of charge passing through it when you are going to do a RCPT test, which is a rapid chloride ion penetration test, whereas a high strength concrete would be somewhere close to about 1800 or so. UHPC typically would show much lesser than 250 coulombs passing through it, which means the particle packing being that type, it does not, or it really inhibits the transfer of chlorides or water through it. Extremely watertight. Also, this is from a quick accelerated corrosion test. If you look at HPC, even high performance concrete, to UHPC, which is, time to first crack, you will see that the time to first crack in UHPC is more than double of a high performance concrete. Again, that means, great help towards durability and, longevity of the structure. Next slide, low porosity. See, high performance concrete could have 5 to 7% porosity, concrete might have 7 to 10, mortar might have 15, but UHPC is a kind of mortar which will have a porosity of only 2 to 3% in general. Chloride diffusion, we are talking about diffusion this morning, and if you look at UHPC, I want you to look at these numbers. The chloride concentration is almost next to negligible at 4 mm depth in UHPC in general. So very low out there, and that's where it is helping projects worldwide to improve the life of your structure. Carbonation, UHPC tests 1 year, 0 carbonation. It might be less than what could be measured on that instrument, but it is pretty much negligible, let's put it that way. So, few other things, there are a lot of questions which are floating around, and I get a lot of questions as with regards to UHPC, so I thought I'd put a few slides over here. So questions come that UHPC can only be precast in a facility. So no, you can use UHPC or you can mix UHPC at any place in any way. It can also be precast on site. World over, premixes are being sent in jumbo bags. There are a lot of companies who are selling premixes, and they just go on a site, and all you do is add your requisite amount of water or ice, and then your steel fibers to mix the UHPC, because it's already a premix, it's already a quality control mix. So the only quality that you need to maintain is your water content, and then of course your standard operation, operating procedures as far as mixing is concerned on the site. Rest things should be able to take care of themselves. You put UHPC at any height you wanted to, and also you can cast that in place. So again, it's not just that it has to be precast. Go to the next slide. And UHPC can be pumped. So we have done a few good trials of pumping UHPC, and in fact in the next 15-20 days there is a project we are going to pump UHPC at least 13 stories high. So yeah, we are taking, we are definitely nervous about it, because it's a whole, it's a big project, it's a big quantity which needs to be pumped up, and we're just trying to take all kind of precautions with respect to that. But we have done good amount of trials, so we're just waiting for that end result. Also, there is another myth that is going around that UHPC really has to be steam cured. I just want to put it this way. A long time back, 15 years back, 20 years back, there were a lot of lab trials that were done with steam curing, and UHPC steam curing requires to be done somewhere about 90 degrees Celsius and about 48 hours, and it needs to be the same on all the surfaces. But that's good for your lab, but when it comes to major elements on the site, there's no way that's going to be possible. And majority of the projects today in the world, they are not really using steam curing. Water curing is fine enough, or putting a curing compound is also decent enough. And I can tell you that water curing, one of the projects, this is a 30-day mean, about 186 MPa on site, okay, after the cube test, with a standard deviation of 8 MPa. That's on the compressive side. and then again an overlay. And we are going to talk about overlay today because we are going to talk about durability and how and where UHPC should be used. But just wanted to take you over things about UHPC a little bit. And this is a little overlay test that we did on a very small patch in Mumbai. And we used curing compound over it, and 3-day strengths achieved were about 117 MPa on it. We talked about how UHPC, at any point of time of your structural deterioration, if you are able to use UHPC for your repairs, you may not have to look, for the entire life cycle anymore when it comes to that particular patch of repair. So, few quick examples. This is around the world. In Canada, they put they repaired some old bridge piers using UHPC. They just put a cover of 100 mm thick UHPC all around, and some strengthening was also done. Very quickly, expansion joints. So on 2-3 span bridges, what they're doing is using bearing for translation, and what they're going with is, instead of using your typical expansion joints, they're using something called as a UHPC link slab, which is able to take up rotation. And expansion joints deteriorate very fast. But if you are able to use UHPC in lieu of an expansion joint, you should be good. So, again, filling of joints, where joints are a problem. This is again a repair, a repair issue. Joints were opened up and UHPC was poured into it. Now, because UHPC is such a robust material when it comes to mechanical properties as well, and of course durability properties, the joints are not the weak links anymore. So once a joint is done, it's good. Typically, your joints are always the weak link, one way or the other in vast majority of the projects, but with UHPC, it need not be. Next slide. This is Switzerland, and if I can show over here, a lot of patch repairing work has been done with UHPC. So old girders, new UHPC being poured, just new ways of repair so that life can be improved. Let's see. Seismic rehabilitation. So this is seismic repair again in Canada. On the bottom part of the bridge, you're going to see that UHPC has been put in, and seismic rehabilitation has been done. Oops. So this is a Mission Bridge in Canada. Sorry about that title jumble up over there. And this is one of my favorites over here. Look at it, and this is in Venezuela. Typically when we talk of UHPC, we are talking of countries like US, Europe, and those kinds, and Japan, but we never talk of Venezuela in any of our projects. But here in Venezuela, old piles were repaired using just a 30 mm jacket of UHPC. And according to them, the life of the piles have increased by another 60-65 years. So instead of replacing that highly dilapidated pile over there, they were just able to do the repair work using UHPC and move forward. As more solutions out there, even reparation of your steel girders, etc., using UHPC. But let me quickly move forward, and I'm going to show this, and why I'm going to show this. Just 2 slides on international bridge projects using UHPC. I don't have more on it, and there's a reason I don't have more on it, because I strongly believe, although UHPC can be used for girders, no problem, but I think its right place is more into durability and repair related work. Girders can be done. They may not be cost effective most of the time. And these are some early examples of very nice bridge work that has been done. slabs, waffle deck slabs, more small girders, some pie-shaped girders. So people have done everything, and most of these are not new. I mean, the bottom what you see is more than like 15 years old. So UHPC being new in our country, but a lot of work has been done 15, 20 years back. The top right, of course, is slightly newer. In the last decade, this was in southern France, in a place called Montpellier. And some beautiful aesthetic work. Now that is where I don't have any hesitation, because most of the time architects spend a whole lot of money when it comes to aesthetics, and they could very well utilize UHPC to come up with nice aesthetic pedestrian bridges. And my favorite again over here is this small little pedestrian bridge in the Czech Republic. Why it is my favorite? Just looks like a steel plate that has been bent and put together. There's nothing more to that than that. And that's why there is also a company in the US that sells UHPC by the trade name of Steel-like. So they don't call it concrete, they just say it's like steel. And obviously this looks like a steel. I'm just going to quickly run through our some applications. This is where we started off in the country, doing a lot of girders for buildings purposes, more 19-meter girders, post-tensioned. Of course, in each one of our projects, they have been done to solve one problem of the other or the other. So one project where the spans were already 7 meters, and at the top floor, owner wanted 14 meters. We went with UHPC, reduced the loads, the self-weight of the structure. Another project, we went in where not too much load again could be put on the structure, so we created a 19-meter UHPC beam. This was something that we just tried out, and it is going on a 6-story project right now. Needs more refinement in terms of the constructability process, but this is a RC outside and a UHPC inside, composite column. More UHPC. These are short span beams, just has 3 number 12 rebar at the bottom. No pre-stressing or post-tensioning in them. Let's move forward. More miscellaneous work being done, ripped slabs and stairs, architectural stairs. Before I digress too much, I'm having a difficulty using this one. More repair work. More architectural extension work. This is something I want to show though. A project on which not enough development length was available for the rebar. And one thing you want to know, UHPC also has extremely high bond strength. So while the development of a typical rebar in normal strength concrete, etc., could be ranging from 40 to 50 times the diameter of rebar, with UHPC you just need 15 times the diameter. You don't need anything much. So that's where you don't have enough development length, etc., available. You could at least splice it with UHPC, and then that's what we did over here on a column. We did the splice with UHPC instead of trying to add more rebar to the column or epoxy rebar into the bottom existing column, and thereafter, the UHPC, the normal concrete work started again. Let's see if it can move forward. This is where the pumping is going to go on. Next, please. There's another project where we are coming up with V-shaped UHPC precast columns, and the top left is all precast. Oh, sorry, the top right is where today a girder is being placed in Mumbai. UHPC girders are being placed as we speak. More projects to show, but I'm just going to skip those because I want to speak a little bit more on durability and overlays. So coming to overlays, this is where I want to focus my attention for the rest. I think this is where the future of UHPC in the country should be there. Overlays and joints on bridges, on the bridge decks. Why I say that? UHPC is so robust, not only your RCPT values are down, your particle packing is so tight, so moisture penetration is quite low, but even for border areas of the country where bridges are there, freeze thaw is a huge problem, and UHPC is extremely good in freeze thaw too. So in a variety of ways from the north to the south of the country, if you are able to put UHPC as a very thin topping on top of your bridge deck or bridge slab, you would have a long life of the slab by itself. And this is where I think UHPC should actually move in. Next, please. And let me show you this slide over here. You see a typical UHPC overlay. UHPC is also called UHP FRC. There's no difference, okay? Just the word fiber comes into it, ultra high performance fiber reinforced concrete. But UHPC and UHP FRC are both exactly the same. But typically for an overlay purpose, you would go somewhere about 30 to 40 mm on a bridge deck. Only if you have to do major repairs or strengthening of the existing slab would there be a need to add some rebar to it. Okay, and then too you can get it done within a 50 mm thickness, nothing more than that. Next, please. So here is a quick picture of the Swiss viaduct, is the Chilean viaduct, wherein the entire viaduct was overlaid with UHPC. The deck was also strengthened. This was quite an old structure, but what they again claim is the life of the structure or the slab has improvised by 75 years. So a huge paver, concrete paver is being used on this particular project. They mixed UHPC on the site by putting up a batching plant right on the site, and UHPC was put front. Now this is not a self-leveling UHPC, okay? The UHPC that they put over here was a thixotropic mix. All you need is a little bit of an energy into that thixotropic mix, and it's very workable. So otherwise, all kind of slopes are there on these bridges. UHPC would just flow away if you just put a self-leveling or a flowable UHPC. So that's how it looked on that. You can see the concrete paver out there. Right behind the paver, you can see the completed work. In front of the paver, still work needs to be done, and the overlays, stretching the entire deck. Next, please. Another small bridge. Now, in Europe, see, US, they do it differently. US, they do not put any bitumen over the UHPC overlay. In some parts of Europe, they still do that as part of the specification which has been there for long. So this one was a 30 mm UHPC overlay, and over that there was a 40 mm bituminous concrete. Okay, so a little bit different, but you see again, as a measure of protection, UHPC was done. In fact, let me tell you, overlays has taken over any structural UHPC work in terms of bridges, and a majority of bridge deck replacements, etc., which are taking place right at the moment in the US, especially in California, they are going in with new concrete overlaid with a 30 mm UHPC right on top of it. Now, I do want to show you this. This is, a very, very simple air screed that is used. If you have a very small project, air screed could be used. Right behind you have UHPC on which curing compound has been put. Look at this surface preparation. Extraordinarily good surface preparation is needed for bonding purposes, and I'll talk a little bit more about it. But again, this UHPC was made on site with 2 mixers and just pre-mixes coming to the site, being dumped into those mixers, and then addition of your ice and steel fibers. So robotic hydrodemolition, one of the best ways to do your surface preparation, whether you're going to lay UHPC over it or whether you're going to lay concrete over it. And therefore, I just put this huge magnified, image over here, all credits to a company called UHPC Solutions. But hydrodemolition machine in action over there, and that's what you get. So you don't need to put any bonding agent over the overlay. Okay. About 6 hours before you put your UHPC, start sprinkling some water over it. Like you would do, have a nice pesticide plastic little sprayer with you, and you have water in it, and you just spray, nice misting, I would say, just mist out every couple of hours, just mist out your, or 1 hour you put mist on your slab, and that is good enough to overlay UHPC, but you don't need any bonding agent. Please don't put it. Next, please. Here is an image. So the first one that I showed was of a massive machine being used in Switzerland, concrete paver. Now there are new type of micro thin lift UHPC pavers that have started coming, specifically for the purpose of UHPC overlaying. And they're very easy to use. And you can do anything from a range of about 2 meters to however long, 10 meters that you want to go. So you can go wide, I would say, in terms of width. But these pavers really make sure they are laser guided, and because the thicknesses are so low, about 30 mm or so, you can get really precise surfaces even on slopes. So that's, on slopes you would need that. If it's an almost straight bridge deck, you can just go with an air screeder. But anywhere there is slope, you would want to use a nice concrete paver or a UHPC paver. Again, this is a picture I already showed, of some example that we did in Mumbai. This last but one slide over here. Look at this. Maybe the initial cost of UHPC is a bit higher. Yes, it is. It is going to be. But over the life cycle of your project, the number of times you overlay with bitumen, the number of times you're going to repair a concrete deck or rehabilitate it, UHPC top layers over a 75 to 100 years is going to be much, much cheaper. So with that, I just want to come to this. Let's protect now and save the future, because with UHPC, you can help to reduce your taxes on petrol, you can lower traffic delays, you can build up our forex reserves, and you can divert your funds towards other development projects. And that's where I believe that UHPC can be and will be a game changer as far as durability is concerned. So, yeah. Thank you very much.
Thank you, sir, for the presentation. As a token of appreciation, we would like to present a memento to Dr. Satish Jain. I kindly invite Sri Saju SS, Senior Bridge Engineer, PWD, to present the memento. Thank you, sir. Next, we will have an online plenary keynote address by Professor Geetam Tiwari. Professor Geetam Tiwari, professor at Department of Civil Engineering of Indian Institute of Technology, New Delhi. Professor Geetam Tiwari involved in interdisciplinary research, including traffic safety and public transport systems, since 1997 as as a member of the Transportation Research and Injury Prevention Program at IIT Delhi. She has received several recognitions. Some of them are International Velocity, Falco Second Prize Barcelona, Women Acquire Award from Lucknow Management Association in 2010, etc. We are all very pleased to have Professor Geetam Tiwari is here to discuss the topic of traffic safety and road design. Without further delay, I welcome you, ma'am.
First of all, I'd like to thank the organizers for inviting me to this very interesting event and sharing some thoughts on highway safety. So I will share my screen and move from there. Okay. So I hope my slides are visible to all. All right. So in this next half an hour or 40 minutes, I would like to cover this topic, highway safety challenges and opportunities in India. And as we know that the number of deaths on our roads, including highways and urban both, has been increasing for continuously. We still haven't been able to arrest the trend. And in this current slide, we see the numbers plotted from 1970 to almost about 2019, 2020 data is not clear. And the two lines show the total number of deaths, and the dotted line is showing number of deaths per 100,000 population. So the rate seems to be leveling off, yet not showing any declining trend. But if you see the total numbers, it has been increasing. And this is actually quite worrisome, because as we improve our highway expansion programs, we do have a lot of emphasis on increasing our highway construction length, quality, etc. Unfortunately, we have not been able to reduce the numbers. So in this particular one, we are showing a number of, now we can actually try and understand where the problem is by breaking it up into state-wise, and within states also we can see what is happening on our state highways, what is happening on our national highways, etc. So the current slide is showing number of total number of persons killed in road accidents in different states on state highways. And you see the different colors. We have plotted data from 15 to 2019, and actually this is kind of showing us the trend where over the years, is it increasing or decreasing? Unfortunately, we see that in most of the states. And the highest number, of course, in terms of total number is Uttar Pradesh, followed by Tamil Nadu, Maharashtra, Madhya Pradesh, Karnataka, etc. So the bigger states, on the state highways also we are having a lot of deaths. This kind of breakup we could see in terms of national highways and state highways and other district roads also. So in the current slide, we have tried to plot systems approach emphasizes that we have to pay attention to the structural analysis of injury producing systems instead of focusing on individual errors, etc. So the focus here is on the injury causing properties of systems rather than on the errors of owners, designers, and operators. And if we translate this particular theme to road traffic or highway safety, so it is basically saying that we have to understand the injury causing property of the events when there is a crash between, say, a vehicle with one vehicle with another vehicle or vehicle with another object, instead of focusing too much on the errors that any of the road users are going to make, either as a driver or as non-drivers on the road. And this says that we have to move away from conventional explanations which are myopic in nature. So oftentimes when the police is looking at the crash, they only look at the event that happened right at that moment. That is what is myopic. It is not thinking too much about what could have been done before the event, before the crash occurred, and what could have been done after the crash occurred. So eventually the World Health Organization has been promoting these 5 pillars for safe systems approach, which basically says that yes, we have to care about humans which make errors. Humans are vulnerable to injury. Everybody has to share the responsibility of ensuring that the number of deaths and serious injuries reduce due to traffic injuries. We should not accept death or serious injuries, and we have to be proactive instead of reactive. So these 5 principles basically become important, and since 1997 many countries have been talking about Vision Zero. That means sometime in future we should have 0 deaths on the road. When this vision was stated in Sweden in 1997, this was adopted by Swedish Parliament, and at that time engineers were quite clear that we don't know how to achieve this vision. We still do not have all strategies in place. However, if this is a vision, then as scientists we have to work towards achieving this vision, and by implementing various interventions and documenting how successful these interventions are and what else additional strategies are required to achieve this vision. So this vision is part of this safe systems approach, and once we start translating it, what does it mean? So these 3 important aspects, and especially the first one becomes really important for people who are involved in designing roads and infrastructure. So the first most important thing is that we have to design a road environment with an infrastructure which is adapted to the limitations of the road user. So this recognizes that as human beings, when we are using the road, either as a driver or as a non-driver, we are liable to some people will make mistakes. Some people will be careless. Some people will be bad drivers. However, for that behavior, the infrastructure design should be in such a way that there is no death or serious injury. Second, of course, that vehicles can also be equipped with technology and all vehicle designs which simplifies the driving task, and it protects the vulnerable road user as well as the car or the vehicle occupant. And the third important aspect is that road users that are well informed and adequately educated. So important aspect is the sequence of these 3 broad strategies. If we focus only on educating an awareness program, the historical evidence shows us that there is no benefit whatsoever. We are not able to reduce number of crashes or deaths on the road. However, if we focus on the first one, changing the road environment and infrastructure design, almost 60 to 70% of the problem is solved just with this. Not 100%, however. Improving vehicle design and below this the relationship between function, form, and use. So basically, it says that depending on the function of the road, its form is to be decided, and that is how it is used. So if I give a specific example, if we have, let's say, an expressway, so the function of the expressway is to move high-speed traffic. And for that high-speed traffic, all geometric features are to meet that high-speed requirement. And once we design it, wide lanes, broad shoulders, straight roads, then that is how it will be used. People would be comfortable in driving fast. On the other hand, if the function of the road is that it is passing through a village, it's an ordinary district road, major district road, or minor district road, the function is not to have high-speed traffic, but to have traffic which is only moving at 40 to 60 kilometers per hour. So the road design, the carriageway design, the shoulder design, that all that would be accordingly changed. And once that is changed, then its use also is according to that. So in a way, our road design is having an influence on the way we drive on the road. So, and especially Government of India is also signatory to Vision Zero. Our ministry is also saying that sometime in future we should have 0 deaths on the road. So if we have to, as designers, if we have to understand this and translate this into our highway design, basically we have to understand these 3 important aspects. The zero vision is based on the notion of allowing incidents to occur, but at a level of violence that does not threaten life or long-term health. So it basically means that we cannot say that there will be no accidents. There may be accidents, but the system design ensures that these accidents or these incidents do not lead to deaths or serious injuries. In the zero vision, the entire transport system must be designed to accommodate the individual who has the worst protection and the lowest tolerance of violence. So you think about our highways, or even on our highways and most of our roads, pedestrians, motorcyclists, and bicyclists are present. So we have to take care of them. The responsibility for every death or loss of health in the road transport system rests with the persons responsible for the design of that system. So clearly that is highway designers. And this is the ethical basis for realizing the zero vision. So Klaus Tingvall was the Swedish person from Ministry of Roads and Highways, which actually talked about Vision Zero and stated what is Vision Zero. Okay, so 2 important things that we should understand as scientists or people interested in reducing these undesirable outcomes. We are looking at scientific methods and we want to create evidence-based interventions. So we have to collect relevant data. We have to see if a certain intervention has been done. Is it leading to desired outcome or not? But important thing is that a lot of data that we collect is based on our understanding of the phenomena or of what we are trying to explain or understand. So let's give some example. If the theoretical understanding for traffic crashes is that driver error causes traffic crashes and driver training can reduce traffic crashes, then the data collection process will focus on driver related data. So we will collect a lot of data related to whether driver had a training or not, what was the age, whether he had better eyesight, etc. And whether he had knowledge about driving rules. And of course, then we can make all the correlations and come up with those answers. However, if the theoretical understanding is that driving behavior is influenced by the roads and traffic characteristics, so what was explained earlier, broad, wide, straight roads will invite higher speeds, whereas narrow roads, winding roads, drivers would feel uncomfortable to speed up. So there is very strong relationship between the design of the road, the geometric features of the road, and the driver behavior on the road. So if this is our theoretical understanding, then we will end up collecting more data about road and traffic characteristics, road geometry, operating speeds, traffic volume, type of vehicles, and then we will try and explain the factors behind road crashes. So this is important, that what data we collect is based on what we believe in. And if we focus a lot on legislation, which we have been doing, and educational measures to improve road safety, LMICs, low and middle income countries, because even global literature says that, it is assuming that these standards, the highway design standards, which we are using for constructing roads, they are very good. They are good enough to ensure safety. And therefore, if we still continue to face problems in our countries like India and other low and middle income countries, then appropriate legislation, seatbelt use, speed limits, alcohol control is all we need to improve traffic safety. But I think we can question this. Why we can question? Because a lot of standards that we are using, especially designing for high-speed roads, is not meant for mixed traffic. For example, you see two pictures, and these are both 6-lane divided national highways, where in both cases we are seeing mixing of local traffic with high-speed traffic. Even when we are designing these 4-lane or 6-lane divided national highways, it is passing through small towns and villages. Those sections easily spread at least about 1 to 1.5 kilometer. So the highway passing through a town or village which has a very different traffic mix and requirement of safety, but we are designing these high-speed roads there. This does not happen in countries from where we have borrowed all the road design standards. We have a large variation, speed variation on our highways. The first one, you see examples from various national highway and state highway segments, and you see the difference between the 50th percentile speed and the 85th percentile speed. And it is quite high. So there is high speed variation due to presence of non-motorized traffic, tractors, small vehicles on the highways. And the next graph is showing you different type of vehicles which are present on our roads. And we have quite a bit of motorized two-wheelers present on our roads, three-wheelers present on our roads. So our highways are very much like urban roads. So if we are only using standards which are meant for high speed through traffic, then we can actually question these standards, or do we have to design our roads differently? So first, 3 principles that we have to revisit using these principles are standards. So for Vision Zero Safe Systems approach, first principle is recognition of human frailty. Human beings have, a body has only up to certain limit we can tolerate the impact. Beyond 30 kilometers per hour impact speed, our body is not able to withstand. And we should also accept human error. So basically, even after a lot of good training, good driver education, it is not possible for 100% of the drivers to never commit a mistake. Or as pedestrians, our judgments can be wrong in many times. And so we should accept that drivers and other road users can make a mistake. But for that mistake, principle 3 becomes very important. Our responsibility is to create forgiving environment. And this environment is created by using all scientific principles through which we can do appropriate crash energy management. So pedestrians will make mistakes in judging the possible risk in the system, whereas drivers can make mistakes in adopting an appropriate speed. So what can we do as a designer that for these mistakes, the driver or the other road users should not end up in a fatal crash? So we've seen that and we will see that in because we have different types of non-urban roads also, the design speed may vary from 30 kilometers to 90 kilometers per hour with a road cross section designed for appropriate crash energy management, depending on the land use patterns around it. And for us, speed compliance is most effective by design, which means active speed control measures are more effective instead of only relying on enforcement of legislations and etc. So this is not saying that we should not have enforcement. We should have enforcement. However, if we do speed control by texture change, by audible markers, by rumble strips, changing geometric standards, then its effectiveness is much higher. And good road design will make other enforcement also issues easier. So so before I show some challenges and some possible solutions, I want to share with some, a systematic review of the current literature. What is the evidence gap that we find? And this exercise we have just completed in last 2 years, looking at almost more than 20,000 published literature to see where are we lacking as far as evidence for road safety measures is concerned. So the literature review was done in 5 different heads, and I'm going to share only which concerns road designs, infrastructure, and traffic control for interventions related to these aspects for controlling, improving safety. And this is important because road design has actually plays a major role for avoiding crashes, as well as at the time of crash, appropriate design can reduce the severity of injury. So before crash, it can influence driver behavior in adopting appropriate speed. It can encourage pedestrians and bicyclists to use the safe paths because it depends on good quality and design of the path. And of course, divided roads can avoid head-on collisions, and roundabout installation of roundabouts and proper design of roundabouts can avoid 90-degree collision at intersections. At the time of crash, the severity of injury can be reduced by road design elements if we have proper crash barriers, if we have proper design of intersections, introducing roundabouts, etc. So both before for crash avoidance and also during crash, road design has a very important role to play. So this evidence, this literature review was done under these 7 heads. And the major outcomes one was looking was that the study should report what is its impact on fatal crash, on non-fatal crashes, and in change in speed. Because there is a very strong correlation that with if there is a reduction in speed, it will definitely lead to reduction in fatal crashes and all crashes. So, and for each aspect, lot of detailed design features were studied. So I won't go through all the list, but just to give you an example, for protective infrastructure, we were looking at guardrail designs, what happens in terms, because guardrail designs are important for reducing the impact of runoff road collisions. Crash cushions are very important, which are intended to reduce the damage to structures, vehicles, resulting from motor vehicle collisions. Roadside safety treatments are important to reduce dangers for collision, etc. So all these aspects were included. And then similarly, one aspect was looking at designs for bicycles, for powered two-wheeler, motorized two-wheeler, and pedestrian paths. And specifically, these 5 type of designs were included in the systematic review. So what was the outcome of this exercise? First thing we found that majority of the studies have been published in road design and urban form, in speed control for infrastructure, traffic control, and junctions. But very few studies are talking about protective infrastructure, which are very important for highways, and also what impact it has on bicycles, powered two-wheelers, etc. And this is very important because this basically protective infrastructure and as well as aspects of bicycle and motorized two-wheeler is important for countries like India, because this is where majority of our victims are. And we don't have, that systematic review shows that we don't have enough publications in that area. And we also tried to see that whatever has been published, which part, where are these studies being done? Because the conditions existing in South Asia, countries like India, are quite different from North America and Europe. And when we do this for under various heads, topics which were studied, you see in this graph, the dark blue and yellow is the most dominant color. So dark blue is all studies which have come out from North America, and yellow is Europe and Central Asia. So this is again a major gap, that when we do this review of existing evidence, what is working, what is not working, we don't have enough studies coming out from South Asia and places which is relevant to low and middle income countries. So now we can see that the studies, I mean, science works everywhere. So it doesn't matter whether it's in North America or any other place. However, we can try and understand whether it is completely transferable to our case or not. Few other topics, we did see that there are large number of, studies are evaluating impact on motorized traffic, but very few studies evaluating impact on non-motorized traffic. So let's look at what are the transferability issues. You know, the studies, the good quality studies which have come from high income countries, North America, Europe, can we transfer these results and use some of it? So the answer is yes, of course, we can have a lot of learnings from this, but where is the different problem? Let me skip this. I will come back to this vertical curve issue. So first, just a reminder that the conditions we are talking about is quite different, very mixed traffic. Pedestrians present on highways. In this picture, they are crossing, jumping over the fence. Shoulder is used by a lot of slow moving vehicles, and shoulder is also used by non-emergency activities. These conditions do not exist in countries from where we have good systematic reviews. So now, Rune Elvik is a very well-known Norwegian safety expert. And in one of his very much quoted paper, he showed that whatever is done on road as an intervention, it has two impacts. First is called engineering effect, and the second is called behavioral adaptation. So for example, if we widen the shoulders, now shoulders are meant for emergency maneuver for vehicle which is requires a vehicle which is going off the carriageway, it should have enough space for recovery. So shoulder is very important for high speed roads. So, and that is why we expect that a wider shoulder will give us benefits, because there will be more space for emergency maneuvers and vehicle recovery. And the studies which we reviewed from done in US and Europe did show these impacts. However, the behavioral adaptation of this feature is that if we have wide shoulders and wide straight roads, then drivers adapt to this and they start driving faster. And this is what we observe in many of our roads. This would happen in US also, but the serious implication for our roads is that our shoulders are used by we call it vulnerable road users, people outside the car. We do have, in the previous pictures, we saw a lot of slow moving vehicles, pedestrians, bicycles, etc. present on that part of the shoulder. Now they are exposed to higher speed after widening the shoulder. So what do we expect? Then obviously these VRUs are going to face higher risks. So the widening of the shoulder will not have the same impact in high income countries or countries with very homogeneous motorized traffic as compared to the kind of highways we have. So some of these aspects we have to understand carefully whether we are able to transfer that result or not. So another example is raised median. So this systematic review looked at a lot of studies. All these 29 studies were not done in low income countries. They were done in United States, Australia, Denmark, Norway, Germany, and Malaysia. And the result was that after installing the median, the central median, and also the raised curbs on the side, there is benefit. But what intrigued us that when we got into a bit of detail of this, and let me just show you this slide. When we looked at which studies were included, we found that these were the 4 studies which met all the detailed criteria were done long back, 56, 62, and 72. And there was one study which talked about curved shoulder, which came in 1996. So these very, very old studies had looked at the raised median when it is raised more than 200 mm, which is the norm on our highways. After that, this issue was settled in these countries, and medians are never made more than higher than 200 mm. So the systematic review that we are looking at are talking about raised medians which are lower than 200 mm. And AASHTO very clearly says that vertical curbs should never be used on high-speed roads with speeds greater than 70 kilometers per hour. So some of these details also we have to see very carefully what happens. Now, what are the risk factors? One of the most important risk factors that repeatedly several authors have found is speed. And driving speed is one of the behaviors affected by the driver's perception of road safety. It is not necessarily compatible with the road design. If a road design is very forgiving, that means if we make wide shoulders, wide lanes, no curves, then the driver's confidence rises and the perception is that it's very safe to drive, and they compensate this by speeding. And if the speed chosen is not appropriate in a given situation, it of course results in loss of control and run-off road accidents. So lower speeds can be achieved by several passive measures such as speed limit signs, road markings, speed humps. We do have a new IRC standard, IRC 99, which gives all the details about this. But all these things have to be linked with the design speed. So if 93% of the fatalities are in low and middle income countries, that's what the latest WHO report says. India is one of this. So if we are not becoming, our highways are not becoming safer, I think we have to do some serious introspection of how we are designing our 2 lanes, 4 lanes, 6 lanes roads and expressways, that what do we need to do? So, okay, here are some specific design interventions that we have to watch out for to ensure safety. We can do different cross sections. What are we doing for horizontal, vertical curves? Surface characteristic plays an important role, marking and delineation, roadside furniture, and work zones and maintenance. So only a few things I can flag out in this today's talk. So as road designers, we know that there is something called design speed and there is posted speed limit. All current literature shows that there should be no difference between the design speed and the posted speed limit. Because if we adopt a higher design speed and say design speed 120 kilometers per hour, but we put the speed limit sign as 100, then when as a driver, as a road user, we drive on that road, we find it absolutely comfortable to drive at higher speed. So that encourages more speed violation. So if we do want people to drive at 100 kilometers per hour or 80 or 60, then this is the speed which has to be adopted for design speed. Once we fix the design speed, then we already know as designers that all road features, road design elements are linked to that. So if we are designing our highways, expressways for 120 kilometers per hour, then we do need 9 to 11 meters of clear zone beyond the carriageway. And if we do not have this kind of space, that is where we have to go for correct design of crash barriers. And we do have examples of all these different crash barriers, but in all our audits, we find that the detailing has not been, there is very little attention paid to the details, and it, instead of becoming a safety barrier, it becomes actually a major hazard. So for New Jersey barriers, remember the most important aspect is the straight base of the New Jersey barrier cannot be more than 75 mm. And we have to have this chamfer at 55 degrees. Otherwise, this is not a safety barrier. And this is a semi-rigid barrier, a W-beam or tri-beam. W-beam is only safe for small cars. And if on our highways we have a lot of trucks and buses going, we have to go for tri-beam. And it's a semi-rigid barrier, so therefore the post cannot be in concrete base. It has to be only drilled drilled in compacted earth. The moment we provide a concrete foundation here, it becomes a safety hazard and not a safety barrier. There are flexible barriers recommended, but there are very clear specifications where it's applicable and where it's not applicable, and how much space is required for deflection. Audible markers have been found to be very effective. And this leads in, even in other countries, people have documented 14% reduction in run-of-the-road crashes. These have been found to be very effective in marking the shoulder edge line, also median lines. This still has not become part of Indian Roads Congress guidelines, but perhaps we have to start experimenting with this and including it in our guideline. Now, here are some examples. I'm sure most of you are familiar with it, but there are a lot of poor detailing existing on our roads. And you can see this on a newly constructed expressway. This detailing, the joining of two rails of W-beam is incorrect. We cannot have any raised median in front of the this semi-rigid barrier, because then the tire will first hit this, and the moment tire hits at a very high speed any vertical surfaces, the tire will burst. It has nothing to do with the tire design or the tire pressure. This raised median beyond 200 mm is completely wrong. We cannot have, and no standard, even no Indian standard says that we should have these kind of raised medians. So raised medians are hazardous, which lead to crashes. Trees, small structures, gantry signposts, all these cannot be in the clear zone in high-speed roads. In general, so I'm just quoting for median and central verge also what AASHTO says. It's not recommended for any high-speed road. For audible markers, we have a lot of benefits and all the specifications are available, which we can start experimenting with. So next few slides, I'm just going to share some current challenges, implementation challenges. And I think as safety professionals, we have to pay a lot of details and a lot of attention to this. Why is this happening? These are all in newly constructed expressways. And you see the gantry pole is inside the safety barrier. So this obviously is not wrong. And even this raised median here on high-speed road does not conform to any standard. All these signposts within the crash barrier, you know that this is wrong. The height of the, if I mean, the crash barrier, both W beam and Thry beam, it is effective only if it is installed correctly. The height is important. The way it is embedded in the earth is important. And if these standards are not being implemented, then instead of a safety barrier, it becomes a hazard. It will ensure that there will be major traffic crashes. You can see this detailing is absolutely wrong. So a vehicle which goes off the carriageway will slide with this W beam barrier and go and hit this major concrete and will be a very, very serious crash. Of course, we have major challenges on our highways. You know, these are de facto bus stops. How do you prevent it? How do you encourage buses actually not to stop here and go to a proper busway? This is something we need cooperation with enforcement agencies, designers, and traffic police, all three working together. So this also, you know that the major problem in this kind of crash is this existence of this concrete wall here. Whether a person is wearing a seat belt or not, of course, the person should be wearing a seat belt. However, this is something very important. There is no reason why we are designing roads like this. And obviously, installation of this crash barrier is also wrong. Otherwise, this car would not drive into this crash barrier. So these are all problems of our road designs. This having a raised surface in front of the crash barrier, again, this is completely wrong design. A lot of toll booths on our expressways, if we make these kind of concrete walls without any proper crash attenuators, minimum having drums with sand and water. So instead of, I mean, this is inviting major fatal crashes. This is ideal for head-on collision. So I think in the end, one can emphasize that it's a very serious problem. It is a serious problem because we do have a lot of emphasis on expanding and making world-class highways. And one of the features of world-class highways should be that every kilometer that we construct, it should lead to reduction in road deaths and road crashes. And if it's not happening, I think together all of us have to look very seriously, do what kind of standards we have to revise, what is the correct design speed on what type of road, how do we ensure that those design standards are adhered to, how we are designing shoulder widths, texture of shoulder widths, so that it is safe for people outside the car also, design of central median, how many times we have to open the gap, provide gaps in central median so that wrong side driving can be discouraged. We can have separation between non-motorized vehicles and high-speed motorized vehicles. Appropriate traffic calming in semi-urban locations or highways passing through towns and villages, and appropriate road crossing facilities for pedestrians and animals. And similarly, in rural highways, again, we have to revisit many of the details about crash barriers, markings and signages, how we design our wayside amenities, and few aspects about vehicle design also. Conspicuity of slow moving vehicles and trucks and buses does make some difference. So we do have actually already some guidelines on that. So I can stop here, and if there are any questions, we can take up for any clarification.
Any doubts or clarifications?
So I can stop sharing my screen.
Thank you, ma'am, for the presentation. Now it's time for tea break, and we will resume the session at 4:15 p.m. Thank you. Infrastructure through enhanced vibration control. I would like to invite Arnab Banerjee to the dais. Professor Arnab Banerjee, working as Assistant Professor, Department of Civil Engineering, Indian Institute of Technology, Delhi. Dr. Banerjee investigates the designing of novel structures and auxiliates of mechanical metamaterial for vibration isolation, shock absorption for resilient infrastructures. Dr. Banerjee was awarded Newton International Fellowship from the Royal Society, London in 2018, December. So, welcome, sir.
Hello. Okay. Hello. Yeah. Hello. Yeah.
I kindly request everyone to enter the venue.
Start. Okay. So, good afternoon, everyone. Thank you very much for introducing me. So, today my talk is that metamaterial towards the resilient infrastructure. So, let's first discuss what is the material and what is the structure. So, suppose if we see any structural system, for example, we can see like the structure like any structure, and so that structure is primarily made of some material. And if we start zooming into the structural domain, then we can start seeing, in the material domain, then we can again start to feel that there are some structure which are primarily like a lattice structure, and all those structures are coming. So, the distinction between the material and the structure is primarily comes from the notion of the scale, that at what scale we are actually going to talk. So, if you see starting from the atomic range, which is something like in the nanometer or maybe the picometer range, and from there we can go to the kilometer range where the bridges and all other structures, the civil engineering structures are lying. And if we see, as we can understand that all the cases like at the very small level we can also have a structure, and at the very high level we can have a structure. So, the internal mechanics is some of the cases is very similar. So, in one case maybe it is interacting with the electromagnetic waves or any that type of waves, like where the wavelength is very small, and some cases like where the wavelength is very large, that also interact with the large type of civil structure. And also another very interesting point, before we jump to the metamaterial, we need to first see that is the periodicity. In our nature, we can see the periodicity almost abundantly in everywhere. If we see like a petals of the flower, if we see the honeycomb of a bees, if we see the cell structure, if we see any lattice structure of like any chemical material, we can see that all are maintaining some level of the periodicity. So that is very abundant in the nature. And if we also talk about our civil engineering aspect, there also we can see the periodicity is not that much rare. For example, if we think our multi-storied building, they are primarily a periodic structure. Like we are having all the floors are primarily very similar. They, obviously, I do agree there is some differences at the bottom and the top story, but primarily they could be considered like a very similar periodic structure. If we see the wall type thing like a panel wall or something, there also we can able to see some periodicity which is something replicating the honeycomb type material. If we see the pile groups, they are also periodic in nature because we are putting them in the periodic nature. If we see the bearings, elastomeric bearing and all those things, they are also having some sort of periodicity. So these are some very few examples where we could able to see the periodicity. There are a lot. So if we try to defining the metamaterial, it is actually a structure having the periodic repetition and emerging phenomena it shows beyond, means which are beyond the nature. For example, periodicity in terms of different type of attachment, means suppose we have some structure having some different type of attachment in the periodic manner, alteration of the geometry, boundary condition and wave coupling. I will do explain with all those things like what are these I want to mean. And also several very unusual characteristics we can able to see. For example, it shows some sort of band structure. I will come into detail what is the band structure. And also sometimes it shows some negative modulus. For example, we can get some negative density, negative Young modulus, negative Poisson ratio. That type of thing we can also often get. And also there is some type of material which can actually is a solid, but it can act like a fluid because its Poisson ratio become 0.5. So these are the different types of the class of material what we can able to fabricate, and they are primarily be part of the metamaterial. So here we can see some of the examples of the meta beam. So you can see in the very first one, we are having a beam that is connected with some resonators in a very periodic manner. So we are putting nothing but some spring mass systems in a very periodic manner, so that it can give that periodicity point. I will come into that how they are means beneficial. You can see that another type of beam structure which are like primarily made like a biconical sections. Then you can see a beam where we are putting some sort of wings out in a very periodic manner. Then we are having few beams, they are connecting using some layer. Like you can put some thick layer and you connect it the several beams one after another. So that thing is possible. Then we can have some spine type beam. So they are actually going like alteration of the geometry you can able to see. Then there is a beam where you can actually able to have like one portion getting elongated and then again getting sorted with a curve type beam. And you can also able to have some sort of active controlled metamaterial where you are sensing from some point and you are actuating at some other level. So these type of different types of meta beam you can actually able to see. So where that periodicity concepts are coming into picture. Now if we see how the mechanics of that periodicity actually working. So if you see a wave is propagating through the beam, then we can very easily write the equation of motion equation for a particular point that y1 equal to minus e to the power of ikx plus omega t. Very simple. So that is the point at certain distance y1. So you can means x, we can see that how much is the amplitude. So suppose if we say that after certain distance, if we try to calculate what is the y2, then we can see y2 will be equal to, just we can place instead of x, we can place x plus a. So we can come up with the equation that y2 equal to y1 into e to the power of minus ika. So this is a very famous Bloch theorem. Although Bloch theorem has a lot more things to do with that, with the electromagnetic wave and all other things. But if we try to relate in a very simple manner. We are having any vector quantity or any wave propagating, we can correlate that after certain distance, this will be the nature of that wave. So, if we try to implement that concept for our beam where we are having some spring masses periodically arranged, and if we try to calculate the state vector means we are having displacement, rotation, bending moment and shear force at each point of the beam. So, if we are telling that okay, where we are having that spring mass, so that is the left end, and then the next unit left end we are having again the spring mass system. So, they are periodic, and using that previous formula we can say that all the quantities they are can be written as e to the power of minus IKA. So, that shear force, bending moment, rotation, displacement all can be related in this form, and that actually helps us to make this nice dispersion equation where you can see that you can establish the correlation with transfer matrix, like you can transfer all the coordinate from one side to another side and you can establish the relationship, and additionally you can get it from the Bloch theorem. So, that actually tells us, and here if you see that k is nothing but the wave number. So, we are getting a relationship between the frequency and wave number. So, that actually going to tells us if we are giving a excitation with a particular frequency, can we get a real wave in the medium or not? How does that signify? If we can get a real wave, that means the vibration can able to propagate. Like we have a structure, we hit at some point, wave can able to propagate. If we are getting a, means if we are not getting any real value, that means wave will attenuate. That means we are exciting at one point of the structure, but wave cannot able to propagate. It getting dissipated within the medium. So, that is actually the sense of the spatial attenuation. Okay, so you can see also very clearly that once we are solving this eigenvalue problem, we can get the terms either in terms of the e to the power of IA. So, here once we are getting that beta is 0, then it will be nothing but e to the power I alpha, that means it is a sinusoidal or cosinusoidal wave propagating. Otherwise, if we are getting beta is non-zero term, then it is getting decayed. So, we can also see that if we are having some type of metastructure, so this thing is actually showing that we are throwing a wave pulse, and that red portion is just a beam. It is not a meta beam. You can see that wave can easily able to go through, pass through. Now, you can see the second one. We are also having a meta beam in that portion. You can see that this wave goes, but it start reflecting back. So, it is not in the very first manner that everything is propagating. You can see that some portion is start getting reflected. And if you see the third one where we have tuned the meta beam in a very proper manner, you can see that wave goes and it will completely coming back. It cannot able to propagate even the full system. So, that we have completely formulated, and that paper get published in the Journal of Vibration Acoustics with that. So, now if we try to see that, we seen there is one very important point, that is we have to calculate the transfer matrix, because once we are going from one side to the another side. So, I do not want to go into the full detail of the transfer matrix, that how we can make it, but you can see a very general formulation scheme, that is we have some governing differential equation. So, we can have that governing differential equation, then we can write down the governing differential equation in the spatial domain, then from there we can make the state space formulation. From that state space formulation we can able to solve the differential equation in its exact form, and once we solve it, then we can again rewrite the full thing in the state vector and variable representation. Then from there we can calculate the coefficients, and we can finally able to get the transfer matrix formulation. So, this formulation we published in 2021 in that paper. So, in there you can find the full details of this method. So, using that two things, we start calculating for the different beam structure how we can getting this type of different dispersion diagram. So, here if you see, once we are doing for this type of beam, like once there is a beam and then we are putting some type of winglet out. So, there you can see that once for some frequencies, so these are actually the excitation frequency. So, in some excitation frequency you can see wave cannot able to propagate, they are actually start getting attenuated. Why this is happening? Because at those point, the vibration of that spring mass system started. So wave is not going propagated, it is getting attracted by that spring mass system. We also do some experiment, and I will also come into that. You can able to see that how it is exactly happening. Then once we are having that biconical section, you can see that we can get some region where that waves are actually getting attenuated in those ways. So, and these are also the procedure that how we can able to solve this. Again, the very similar manner, equation of motion, exact solution, continuity maintain, we can maintain that, and we can able to solve this. Then we have also done for the telescopic one. So in telescopic one, we can also able to see that quite big band gap we can able to obtain. So if we can able to do this type of structure, and we can able to tune it also, that which frequencies can able to propagate and which frequency cannot able to propagate, that we can very easily able to see. We have done for this cup tapered beam. So here in the cup tapered beam, I would like to point out one very interesting point. So you can see this thing is only for the tapered. There is no curvature is included. Now once we started including the curvature, then what happened? Then you can see the axial mode of vibration and bending mode of vibration start getting coupled. And the position, like for example this cutoff junction, you can see, or this cutoff junction, where both the wave has the same wave number, they start interacting with each other. That means like once you are giving the excitation in the axial domain, it can very easily flip to the bending domain without much change of the energy. So therefore, you start getting a standing wave instead of propagating wave. So therefore, wave is start getting attenuated, and these portions start elongated, and you are start getting that band gap portion. Because as we have already seen that if we are having that in the solution b to the b means beta that is greater than 0, then it start decaying because wave cannot able to propagate. So this way we can able to start getting that, okay, wave cannot able to propagate. So this thing we have also studied, and you can find in these two paper that thing. Then we have start interacting that if we are taking some wider beam where the micro rotation we need to start considering, there this micro rotational wave is start interacting with the bending wave and the axial wave, and we can start getting the band gaps in those positions. So some positions we can found where the band gaps can be located. Then we have studied for the rigid and elastic. So for example, you are having some beam where you are putting some portion as a rigid, means elastic part, and then some thick portion which is act like a rigid body. So there also we made that full formulation, and you can able to see we can able to get quite larger band gaps. So that bands actually shows that wave cannot able to propagate in those portions. So we discussed a quite different thing in that frequency domain, but maybe that means in the spatial domain sometime we feel little bit confused, that because we are not that much habituated to see those things in the frequency domain. So now let's see what this type of things happening in case of the time domain, means how they are actually doing the things. So if you see here, like we are taking some system where like we have a system and then we are putting that spring mass type thing internally. So, and we also put some type of piezoelectric sensor there. So that thing can sense, and once that energy is there, so it can start actuating also. So we are putting some transducer. So here you can see that these are the two wave number domain we have considered. So, and in between portion we can able to have that band gap. So with the piezo transducer we can see that band gap can be widened. On the other hand, if you start calculating that how much damping they start introducing, we can see that the piezo, means inclusion of the piezo transducer can provide a huge amount of damping into the structure. And finally, due to that, if you are taking this structure and give a initial displacement to the outer mass and leave it, you can see that the red vibration, what you can see at that point, like that red vibration is quite huge and it is taking long time to get dissipated. But if you have that piezo transducer inside, that can be very quickly dissipated. So we all know that once we are estimating the free vibration problem, that exponential type graph will gives us the value of the damping. So here we can easily say that as in case of the piezotransducer material, our damping get increased, we can get a much faster attenuation. So these are very effective once we are studying anything under the transient type of vibration. For example, earthquake is happening or some wind is blowing. So in that case, the structure is subjected to the transient mode of vibration compared to the steady state of vibration. So there, this type of formulation is actually very much required. So now you can see some of the experiments we have also performed to see that what we are getting are really making some sense, or that may be some sort of like a mathematical fallacy. So you can see that these are, so primarily we doing the testing like this way, that we are taking some vibration shaker, then we are mounting our samples on top of it, then we exciting the shaker with a particular measurement. We are measuring the shaker also, that how much measurement we are giving, is it actually vibrating in that range or not. And then we are calculating, all means we are measuring the different responses in terms of accelerometers. And we also have our own lab view software, so there we can actually able to process the data output. So you can see this experiment. So in this case, you can see we have a beam, and that beam we are putting the two resonators in that. So you can see that in first case, that full structure is vibrating quite vigorously. But now if you are putting that in that resonating frequency, if you are vibrating, you can see that the spring masses are actually oscillating, not the beam is oscillating that much. So that actually one of the key point what we just discussed in the very all those cases, that we are getting some bands where at some frequencies the wave can able to propagate, or that means the vibration can able to propagate, and in other cases the vibration is not actually propagating. So that thing we can able to see from here, that it can reduces the vibration if we are tuning it properly. So some of the applications where we can able to start applying this type of concepts. So you can see that wind turbine tower, which are really nowadays very much important in the reality, and it's a very tall structure. So it is subjected to the wind primarily, means so here we actually start implementing this concept, because we have a so long tower like structure where internally we are making this type of resonators. You can see that like this is obviously like a small experimental level version. We make it in our lab. So you can see that this is like a quite a heavy mass we put in the top, which somewhat representing the wind turbine tower, because if you see that RNA unit, what they are putting in the top, that is very heavy. And there is a very good analogy people are telling, that designing of wind turbine tower is something like you want to put your washing machine on top of a light stick, I mean the street light carrier. So it's something like that. So you are having, like, we made this type of stand, means we do it all the calibrated properly, and there in the inside that pole we are having this type of internal structure. So what they are doing and there we are putting some type of mass in between. So these can actually oscillates and give some sort of vibrational mode. So once the full thing is vibrating, then that can actually able to resist, means take the oscillation. So some particular frequencies, because in case of the wind turbine case, we also know what are the excitation frequencies, or if it is rotating, then what type of frequencies it actually generates, because it is not rotating in any random speed. So from that we can able to design our particular internal structure, and that can able to do that. And we also perform that analysis and try to see that how well, means you can see that proper region where the response can be reduced drastically. So this type of structure we already made, but till now experimentation is not been completed. So we are in process of doing that experimentation. then we are also implementing that similar type of concept for the reduction of the track vibration. Means if you see in case of the Delhi, we are always getting the in the news article that due to the metro vibration, there are a lot of problems, the buildings are getting cracks and all those things. So we also had discussed this problem with the DST and NCRTC. So there we actually start working on this problem, because if you see in the beneath the railway track, we are having this type of pad, and now we are putting this pine type concept internally, and we are fixing that with some elastomeric material, and we try to see can it able to do some sort of vibration insulation or not. Although this project is also in the very initial stage, we have started working on this thing. Then we have also made some sort of vibration control devices with this type of concept. So where we are attaching the rigid mass. So you can see that this mass is primarily like a rigid mass, and they are suspended with some elastic beams with different formations. So there we can actually able to make that matrices, and once we are exciting the full structure, so you can see that vibration, like you can exciting this structure, but you can see that top mass, which I just put an accelerometer there, which is acting like a mass, but that is not that much oscillating. So the primarily the oscillation is going to that support resonators. So this type of thing you can actually design for various type of your applications where we can do that. Oh, and additionally, another very important thing you can notice that once we are putting this type of thing, there in the normal spring mass case, we cannot have any portion which are getting attenuated at this range. But here, we can have a very sharp decay at certain frequencies, and these frequencies all we can actually able to tune, means it is not any random frequencies. We can tune it and we can make all those things as we required. So these are actually some of the applications in the metamaterial. So you can see the attenuation in space, and also you can see that it enhancing the damping in the time domain. So from that space point, it is very effective once we are doing any steady state type vibration. Like for example, a machine is revolving and you try to make the foundation of the machine, or if you are subjected, and it may be subjected to the wind load and it is rotating like a wind turbine case. So in those cases, it is primarily like a steady state vibration, or if it is going for the earthquake, which are very much transient in nature, there we can say it can enhancing the damping nature so that it can quickly come back to its original position. So these are the complete things. So all of my collaborators with whom actually they are contributed a lot, means we all do the work as a teamwork, and then my research team in IIT Delhi, all my PhD and the funding agencies, those who have given us the funding for carry out those problem. And so thank you to all of you for listening the talk. So if you have any question, you are welcome.
Thank you, sir. As a token of appreciation, we would like to present a memento to Professor Arnav Banerjee. I kindly invite Saju SS, Senior Bridge Engineer, PWD, to present the memento. Thank you, sir. If you have any doubt and clarifications, you may please raise your hands.
Yeah. Hi, Dr. Banerjee. Nice presentation.
Thank you.
So I have a question. The recurring relationship that you established in the first part of your presentation. So is there any, if there is any perturbation in your structural system, Okay, that may not be recurring. So have you seen the wave propagation characteristics, how it is affecting? But because that is very much real, right?
Yes, so yeah, I got your point that you are mentioning that is there any perturbation in that thing. So perturbation is like a primarily the recurring type event, like suppose some structure is get shifted. But if you see in case of the linear vibration, the effect of perturbation is also can be means not present, because if you see in the steady state duration, the effect of the transient part is almost dying out, and perturbation is primarily due to the shift from the initial position. And that get actually die out with the damping, means once it goes slowly to, means once it reach to the steady state. So therefore it actually dying out. But yes, you are very correct. Once we are doing for the transient analysis, like increasing of the damping, then it start affecting. But yeah, I did not go into that detail of that. But yes, definitely there
Yeah,
could be some
because
of
for
the
small perturbation problem, I mean structure will not remain, I mean periodic or recurring,
Remain
whatever you are
exactly.
saying, that it may not remain, right?
Yeah, but if you see it is
But
all
with some approximating approach, maybe we can still get
Exactly.
the propagation characteristics.
Exactly, madam. So, as you very correctly pointed out, so here also we have seen that very near periodic structure, means it is maybe not periodic exactly, because suppose one person is vibrating higher and another person is vibrating lower. So, the effective stiffness or the overall stiffness is no longer remain periodic. Exactly. Do you agree? But if you see, they are still maintaining some sort of near periodicity, and we can still able to formulate based on the near periodicity concept. So, and we can also take it as like a graded, like if there is some gradation can be possible to be thought of. So that also we can able to do.
Okay, thank you. And
Thank you, ma'am.
another question. So have you considered any non-linear recurring
We have
in
done.
the structure non-linearity? I mean, that can be considered as a recurring, right?
Yes,
But,
yes.
yeah.
So we have done one with a very weakly nonlinear system, not any strongly nonlinear. So weakly nonlinear system means we can able to address like a small perturbation, and then we can able to see the bookkeeping parameters that how they are actually able to affecting. But obviously we have not done with any strongly nonlinear system. That will definitely going to be a very nice problem.
Thank you.
Thank you, madam.
Good evening. Is there any application can have any significant role in our ordinary constructions, bridge, etc.?
Yes, sir. So thank you for the question. So if you see, it is primarily means primarily can reduce the vibration of the structure. So in case of the bridge, also if you see bridge can be also think as a very periodic structure, like we have the base in a very periodic manner, and if you see the pattern of vibration, it can be also thought that like the fluttering effect and all other things, they are also we can able to put some type of spring mass system or like a tuned mass damper type thing in certain periodicity, so that it can able to reduce the vibration. Recently with one of my collaborator, we started working on the flatter type problem and try to see that can we able to put the meta type of concept effectively there or not. So that we have just started actually working on that. But as you see that these works are very recently started. So we just primarily do mostly the theory part, and some portion we have started doing the experimentation. Obviously, it took at least 10 to 15 years to go for the industry level. Definitely, sir.
Thank you, sir.
Thank you very much. Thank you very much.
We have come to the end of today's session. We have more interesting sessions scheduled for tomorrow. I hope you all enjoy the session, and let us meet tomorrow at 9 a.m. And please note that the copy of the souvenir is available at the registration desk. And also we are distributing the certificate of participation, which can be collected from the registration desk tomorrow. Thank you.